Okay, I want to. Hello, everybody. Welcome to the 9th annual and first virtual ITE technical conference. For those of you who don't know me, my name is Luigi Castanelli. I'm the Planning, Traffic, and Advanced Technologies lead at HDR Engineering. Today is my pleasure to be your MC, and hopefully I can make this event a unique experience for the next 4 hours and keep you on the edge of your seats. But before we start, I want to thank all the volunteers who helped make this possible. Farouk, Marvin, Gordon, Amir, and who are my beta testers for the last few nights, and of course Brian Dempsey, who will be monitoring the chat box. I would also like to thank all our sponsors for their support in helping IT be one of the most successful sections in the United States. And of course, all the presenters, because without them, we would not have a program. And I would like to thank every one of you for your patience in getting this technology moving forward. And finally, I want to thank all of you. In the last 9 years, we've had 14 conferences, over 1,500 attendees, and nearly 6 PDHs. Without your continued attendance, this would not be possible. Now, I would like to introduce to you our IT Met Section President, Marvin, who has a few announcements. Hold on a second, Marvin. Marvin, you're good to go.
Thank you, Luigi. Good morning, everyone. It's great to see such an amazing turnout for today's technical conference. I wanted to take a quick moment to share some announcements from ITE. First, voting for the 2022 ITE International President and International Vice President is now open. You should have received an email containing instructions and a link to cast your vote. The candidates for International Vice President are Mr. Jean Chartier and Ms. Rosanna Correa. The candidate for International President is Ms. Beverly Thompson-Kuhn. Voting ends at noon on Friday, March 12th, so please exercise your right to help shape ITE's future by casting your ballot. Second, ITE International is currently accepting nominations for awards in categories ranging from international awards to student and council awards. Deadlines for nominations are fast approaching, with some coming up on March 1st and others coming up on April 1st. So please visit ite.org and look for awards under professional development to find out more information on available awards, nomination requirements, and their submission deadlines. Finally, ITE International will be hosting its International Virtual Student Leadership Summit from February 19th to February 20th. Registration is $10 for students and $25 for professionals. All registration fees will go towards supporting the Diversity Scholars Program. Registration and event information can be found at itestudentleaders.org. I highly encourage students and professionals alike to participate and take part. I know we're excited to jump to the conference, so I don't want to take up too much more of your time. So I'll hand it back to Luigi to help get it started. Luigi?
Marvin, thank you for the kind words. And I'd like to continue off where Marvin left off with additional industry announcements. Give me a second. I don't know if I'd like to mention recent changes in leadership at both New York City DOT and the Port Authority of New York and New Jersey. First and foremost, I'd like to thank Polly Trottenberg for her service at New York City DOT and for being promoted to the U.S. Deputy Secretary of Transportation. I'd also like to thank Margaret Fordrone for stepping in and help steer the ship till a successor was found. And finally, for those of you who are not aware, we do have a new City DOT Commissioner Hank Gutman, who recently got appointed. And finally, a big supporter of ITE for as long as I've been an ITE member and presented at many of our conferences, Mr. Rizwan Beg, for being promoted to the Deputy Chief Engineer of the Port Authority of New Jersey. I need to highlight this because this is the first time in my career that I've seen a traffic engineer being promoted to such an elevated position, and I want to add, has a PTOE from ITE. It goes to show you, not that I have anything against structural or highway engineers, but it means, being a transportation professional, you can achieve those heights. So thank you. So before we get into the presentation, there's a few rules I want to go over. To obtain 3.5 PDHs, you have to register through the ITE Met Section website. So you could watch this conference, but actually, hold on one second. And as you go through each presentation, at the end of each presentations, you're going to be asked 3 questions by the presenter. To get those PDHs, please respond in the YouTube chat. And also, if you're not logged into YouTube, it's okay. There's going to be an email address at the bottom where you can respond and ask additional questions. Later, we'll have a panel discussion, and we'll use the chat box again and emails to interact. So with that, let's start with our first presentation. So to start this off, our first presentations is going to be about applications of video-based road safety and mobility solutions. It will be presented to you by Paul Saint-Aubin, a senior product manager at Transoft, and also Mohammed El Ghadi, software developer. I'm not going to read their bios. Actually, it's going to be part of the presentation. So with that, let's go to the presentation.
Thank you for joining us today. This presentation is meant to provide you with an overview of some recent applications for video-based road safety and mobility analysis. We will first discuss the challenges with crash-based approaches to road safety and give you a quick background on the important role surrogate safety analysis can play throughout the road safety management process. We will also provide some insight into how the technology works and how practitioners can leverage video-based solutions to improve road safety for all road users. I am pleased to introduce our transportation and computer vision experts today. Paul Saint-Aubin is a transportation engineer and senior product manager for Transoft Solutions Transportation Safety Division, as well as a postdoctoral fellow at the University of Waterloo. He has over 10 years of experience developing, deploying, and overseeing large-scale road safety analysis technologies, including recent cutting-edge work in predictive collision course modeling. Mo El Ghadi is a Transportation Safety Division. He received his bachelor's degree in civil engineering from Kyoto University and his master's degree in transportation engineering from McGill University in Montreal. His background is a mix of traffic engineering and software development. He has experience with many programming languages, cloud computing, computer vision, and video processing. Additionally, he has 3.5 years of experience in the field of transportation safety, driver behavior, video analytics, and surrogate safety measures. And with that, I will pass it on to Paul.
Thanks, team. So today's established road safety analysis practices are largely founded on road safety data collected from historical crash records. This constitutes the visible information readily available to practitioners and policymakers, namely those crashes that are reported by police, emergency medical services, and other operational authorities. But traffic collisions make up only a tiny fraction of all dangerous road interactions. Navigating road safety using crash data only can steer us in the wrong direction. Historical crash data can be missing important contextual information for proper diagnosis, typically underreports low severity crashes or crashes involving some modes of transportation, and it can take a long time to witness these crash events, up to 5 years to obtain statistically meaningful data. By then it's already too late. Indeed, crashes can be very expensive lessons. We can learn a lot more about road safety, and we can learn it a lot sooner by also looking at a complete cross-section of all road user behavior. What can near misses and otherwise undisturbed passages tell us about road safety? Well, as it turns out, we can learn a lot. Serious near-miss events or traffic conflicts unfold on the road every day. Here's an obvious example. These events are considered collision precursors since they contain most or all of the same necessary ingredients that are required for collisions to unfold. So why not look at these in addition to crashes? Naturally, we expect to see more crashes unfold where we also see more collision precursors. More importantly, if we remove the factors that lead to collision precursors, we eliminate collisions altogether before they happen. So this data doesn't take years to collect, and we have the opportunity to collect it before a serious crash happens. With surrogate safety analysis, we can dramatically accelerate access to safety data by investigating occurrences of traffic conflicts over a matter of weeks instead of years. We may even be able to draw conclusions about potential road safety hazards before a serious collision even happens, thereby addressing some of the risk of implementing remedial safety countermeasures. For example, if we find that a pilot project is not turning out the way we'd hoped, we can take action to tweak the project much sooner to correct the situation. So I'm going to pass it on to my colleague Mo, who will dive into the technology.
Thanks, Paul. So I will talk a bit more about how our technology works and how we can use it to improve road safety. Our process mainly consists of 3 stages: detection, tracking, and analysis, and I will elaborate on each of these in the following slides. So the first step in video-based safety analytics is road user detection, which is done using computer vision. The software takes the video as an input and tries to do what the human eye would do. Like this is to see or detect the different road users in each video frame. An example of what the software does can be observed in the following video. As you can see, it's like building a bounding box around each road user, thus detecting it. And the road users are classified into different types, like cars, pedestrians, trucks, buses, based on visual characteristics. Up to 22 road users can be detected now by our software. The percentages here represent the algorithm level of confidence in the detection. Just another example of how the detection works. And then the second step in the process is tracking. In this step, we use the data generated from the computer vision-based detection, and we transform it into positions and velocities at each frame of the video. We do that by calculating the time difference between the different positions each road user was at throughout the video. And in this stage, we also try to reduce the amount of noisy detections or smooth out the speeds. An example of the tracking can be observed in this video, where each road user has a bounding box around it, highlighting its position and a speed like written above that box. And then, using the generated trajectories, we can find the precise movement classifications, providing accurate turning movement counts for all modes of transportation. So we can have the road users, the trajectories classified by movements similar to the figure on the left, or classified by road user type similar to the figure on the right. There are also 2 views here for displaying the data, the camera view, like on the right, and the bird eye view in meters or feet on an aerial view map with known GPS coordinates on the left. So using the trajectories that contain velocities information, we can plot the following speed heat maps. The points here represent the mean speeds at those specific locations. For example, here we can see that the westbound through movement has the highest speeds, corresponding here to yellow and orange colors, around 25 miles per hour, compared to, for example, westbound left turns, like the ones like turning left and going south, which have much lower speeds, around 10 miles per hour. Next is the analysis step, where we use trajectory data to generate safety-related events. Those events are dangerous because usually the users have a limited amount of time to react in order to avoid a crash. Our first safety-related event and the most used one is post-encroachment time, PET for short, that we use for angled collisions. Here's an example of a PET event between a pedestrian and a motorcycle. And here is an example of a PET event between two cars. Another safety-related event we detect is time to collision, TTC for short, which we use for parallel collisions. Here's an example of a TTC event between two cars. And here is another TTC example between a bicycle and a motorcycle. Figures can be plotted using the previous safety-related events to highlight the dangerous locations in the intersection or the study location. Each point here corresponds to a safety-related event. In this example, we are only displaying PET events. We can see that the pedestrian scenarios at the crosswalks are the most dangerous, corresponding to post-encroachment times around 4 seconds compared to vehicle-vehicle scenarios like in the center of the intersection, with an average of over 6 seconds PET. Another output of the analysis section is speeding violations detection. It's like a speed radar. We observe when road users go over the speed limit of the movement or of the site during the detection. And using this, we can find out which movements are more likely to have speeding road users, thus potentially making them more dangerous. So here's an example of a speeding event where the road user goes up to a max of 68 miles per hour when the speed limit is 35. And in this event, the speed limit is also 35 and the road user goes up to a max of 72 miles per hour. Another parameter we can detect is social distancing violations. You can see here in the video, we are detecting the distance between pairs of pedestrians at any moment of time. And we can set a threshold for the violations. For example, if pedestrians get closer to each other by less than 6 feet, that's considered a violation according to most of COVID regulations. So we can plot those violations. Each violation, we know its location and the minimum spacing between the pedestrians during the violation. And we can use that to highlight problematic areas. We have two possible figures to plot here. The first one focuses on the number of violations. For example, here, the upper left corner of the intersection seems to be where most events would occur. Another type of figures here focuses on the value of the violations instead of the number. So for example, here we have a BRT ramp. The pedestrians are exiting the ramp and they walk towards the crosswalk. When they reach the crosswalk, they are likely to get closer to each other than any other location on this in this intersection. And they have an average value of around 3 feet minimum spacing between each other. We can also detect pickup and drop-off events, as well as lane blocking that can be detected for all lanes or specific lanes in an intersection. Here's an example of a car that is blocking this specific lane for around 9 seconds. And additionally, we can detect red light violations if traffic light timings are provided to detect illegal crossings by pedestrians or by vehicles. Here's an example. It's a red light, and this car did not stop. Okay, so I will pass it back to Paul now.
Thanks, Mo. So I'll finish off the presentation by showing how these surrogate safety measures fit into a typical road safety management workflow. You may be familiar with the road safety management process. So surrogate safety analysis can assist transportation professionals in at least 4 of these categories. So with network level coverage, our automated tools help you quickly identify the most problematic sites in network screening. This is like triage of the sites. Once you've determined which sites to study, our technology can be used as a screening tool, allowing engineers to easily identify the most problematic movements or to observe the mechanisms involved by reviewing videos of the most serious traffic interactions. This is kind of like having an X-ray on the intersection. Then our technology also assists in countermeasure selection by linking the observed challenges to treatments available in the CMF clearinghouse. Finally, when revisiting intersections with follow-up after studies, our technology can help identify whether the countermeasure is effective or not. Most importantly, potential problems can be captured more quickly. This makes the countermeasure implementation much less risky. And this phase also feeds back into the network screening to start the process anew. So the general recommendation for network level coverage is a strategy that combines cost-effective one-time deployments to capture network-wide variation in traffic behavior with targeted real-time monitoring at specific problematic sites to capture temporal effects from seasonal, weekly, or time-of-day variation in behavior and weather, and to monitor problematic sites more closely. The strategy may be, in fact, relevant, familiar if you've done ADT estimations before using permanent sites and expansion factors. So with network coverage, we can sort the sites either visually or with lists based on a number of different safety or operational metrics, such as critical conflict rate, excessive speeding, safety score, average annual daily traffic, etc. Then with diagnosis, the system automatically identifies the different scenarios, combinations of movements, and road user types, and highlights the most problematic location, scenarios, and times of day. Videos can be reviewed to get better understanding of the mechanisms behind the most dangerous interactions, helping engineers identify common themes and problems unfolding in the field. This comes with a great deal of rich contextual information. This also provides aggregated data visualizations that Mo has already presented. The diagnosis information is automatically fed into a countermeasure browsing tool that also integrates the crash modification factor data from the Federal Highway Administration Crash Modification Factor Clearinghouse, along with relevant site metadata. Then a list of prospective countermeasures and their CMFs is generated that can be browsed by category. This can save time when performing steps 1 to 4 of the standard CMF selection guide. The technology is especially popular with traffic engineers because of how easily it can be used to study the effectiveness of the implemented countermeasure. Here we're showing a study recently completed for Prince George, British Columbia. The city wanted to measure the improvements to safety for drivers and pedestrians after the addition of a protected left turn signal phase and a pedestrian countdown signal at an intersection with a double left turn. This chart plots interactions measured by the PT before versus after the change was made. We can see that despite similar times of day and similar volumes, we see a drastic change in the number of interactions with low post-encroachment time. This was a good example of a study that showed significant improvements to safety. So the implementation of the protected left phase addresses a major safety issue that can be illustrated in this before video. In the before scenario, a left-turning driver could pass another left-turning vehicle in the adjacent lane that was waiting for a safe gap, as the ability of the passing driver would be restricted by the adjacent vehicle. The collision risk with a through vehicle was substantial. This type of conflict is not observed in the after period. This sort of gets back to the point about the video review. Through this methodology, it's quite clear that using the video, we can quickly find underlying issues by reviewing the video.
Thank you, Paul, and thank you, Mo. Before we get to questions, just a reminder that ITE is now accepting expressions of interest for this year's Vision Zero Design Sandbox competition. Transoft is proud to be providing the key safety analytics for participants. Submissions will be accepted until April 15th. Please visit the ite.org website for details. And with that, we will move to questions. Thank you.
Mohammed, Paul, fantastic presentation. What a way to take crash analysis to the next level. So for all of you, to get PDH credits, our presenters are going to ask you 3 questions, and please respond on the YouTube chat. And if you're not logged on, there's an email address, and you can email directly to Farouk at kinley-horn.com. So with that, Paul, Mohammed, whoever goes first. Actually, hold on a second. Sorry. I apologize. Now you guys start. Paul, now you can start.
Okay. Explain why collision data alone is not always sufficient for complete road safety assessment.
Okay, there's a 10-second lag, but I'm going to start looking at the. Okay, we got a couple of questions. Okay, that's the first. Please respond to that on YouTube. Next question.
Okay, in which phases of the road safety management process could video analytics help the most?
So we'll be waiting for responses. And then the final question.
Name 2 practical applications of video-based road safety technology that could help you on your next project.
Fantastic. So please all respond on. Okay, great. I'm seeing a lot of responses. Perfect. Thank you. Keep responding. Let me go all the way to the top, and we're going to take a couple of questions. So I'm looking at the computer here, and it says, which video detection algorithm have you been using? That's the first question.
Okay, so we use convolutional neural network-based AI based on some open source softwares, but we also customize it. We add our own stuff to it, and we also do some training using like real data to make the detection better.
Okay. Thank you. Next question I have here is the detection and analysis shown all post-processing of recorded data. Is there a real-time component of your technology?
So, Paul, you want to take that one? Yeah.
Or, I mean, if you want, we can respond later on and just send an email, and you can respond to that. The gentleman who asked the question.
Yeah. So we also have like a real-time component. So one software takes pre-recorded videos and processes that, and then another one can do it like almost on the spot with like few seconds delay.
Okay. All right, perfect. That concludes our first presentation. We're going to go to the next presentation and save your questions for the panel. We will have a panel discussion right after this. So we're going to go back to the studio and introduce our second speaker. So our next presentation, it will be on 12 years of transit signal priority, lessons learned in New York City by Mad Macarius, Administrative Engineer and ITS Engineering at New York City DOT. So with that, let's go to the presentation.
Good morning, everyone. My name is Imad Makarios. Today I will present 12 years of transit signal priority, lessons learned in New York City. The New York City Department of Transportation and Metropolitan Transportation Authority, MTA, are embarking on an ambitious program to provide TSB to nearly 6,000 buses in New York City. A key component of this project is broadband wireless infrastructure. Before we had Nice Wind, and today we have AT&T. AT&T supports the implementation of TSB without any additional hardware or infrastructure changes. This approach is particularly cost effective and attractive for widespread implementation of TSB in New York City. Today, our agenda for today's presentation, we're gonna go touch base with background, evolution of TSB. Also, we're gonna talk about TSB architecture, maintenance and operations, and looking ahead what's next. In New York City has more than 45,000 intersections. Among those 45,000, we have close to 13,400 signalized intersection. Also, we have little over 100,000 pedestrian signals, and every year we install between 100 to 120 new signal based on the warrant study. So in New York City, we have about 5,700 buses operating in about 2,800 miles of routes, and that serve over 2 million riders average weekday. Street and traffic signals operated and maintained by New York City DOT. Public transit system operated by MTA New York City Transit. So can I go back and talk about backgrounds of SBS in New York City? So BRT in New York City, which is selective bus service. The features that you see in the little pictures on the slides start from branding, off-board fare collections, all-door boarding, real-time passenger information, RTBI, bus lane, and of course transit signal priority technology. We have about, so far in New York City, as of today, close to 20 routes selective bus service citywide. So in these pictures, after implemented BX41 on Webster Avenue, as you see in the picture, bus lane completely changed in geometric design, etc. So in next section, we can talk about evolution of TSB in New York City. We started Victory Boulevard back 2006 in the Staten Island, and that was a pilot study between St. George Ferry in Staten Island and Forest Avenue, about 2.3 miles. We studied about 14 signalized intersections. This segment has multiple routes. That time we have additional equipment at the intersection and on the buses as well. As you see from the pictures, going in AM rush hour between 6 a.m. to 9 a.m., green arrow, TSB active, and in PM between St. George Ferry going to Forest Avenue in the blue, between 4 p.m. to 7 p.m. We have improvement between 11 to 16% saving in travel time. So next corridors after Victory Boulevard, Fordham Road, Pelham Parkway, that's in Bronx as well. BX12 SBS, the route running on Fordham Road. We study about 35 signalized intersection. That's involved with 2.4 miles. Again, that's required additional equipment at intersection and on the buses as well. As you see here, TSB emitters on the buses. So after we completed 2 corridors in Staten Island, Victory Boulevard, and in the Bronx, Fordham Road, we started first line routes, which is M15 SBS, using the beauty New York City wireless network, Nice One. And that time, we not required install any equipment at the intersection. So it was very easy to implement TSB. So we utilized MTA bus time GPS. We studied about 34 signalized intersection. That involved was 2.2 miles between South Ferry and Lower Manhattan, Water Street, up to Hudson Street, down Chinatown in Lower Manhattan. We had about 4.5 to 18% improvement in travel time. So we built in the house key policies for TSB design. So TSB treatments, which is green extension, early green, or Q jump. As you see from the pictures on the slides, we have a typical intersection 60-second circle length. We can have up to 5 seconds take from the side street and add it to the main street for early green or a green extension. And also we have Q jump, depends on the locations. Also we maintain minimum requirements for pedestrian based on 2009 MUTCD. Also we maintain coordination. So continue with key policies and treatments. We have additional 4 rules in these slides. Door switches means when the door open, no TSB request. When the door closed, the bus can send a request for TSB. First come, first serve. For any routes has 2 directions. TSB duration varies by intersection to intersection. And last one, TSB core recognized only within predefined detection zone upstream of each intersection. So in this slides, we can talk about TSB development. That's with full analysis. We started with data collections, physical inventories, traffic data collections, and then we do data reductions. After we finish all this process, we can determine peak hour for AM, midday, PM, and then we build and develop balanced network map. The simulation modeling scenarios, we have here 4 different scenarios: existing condition, baseline condition, passive TSB, and active TSB. Existing condition is existing. We collect existing in the field and we build a model, existing condition. On the top that existing condition, we built baseline condition, which is in case SBS elements are implemented after initial data collection, so we have to create another model in synchro baseline condition. So with baseline condition, we can optimize the network, and that we call passive TSB. So active TSB, we cannot do it in synchro. We can do it in another modeling, which is in IMSON. And with active TSB, we can develop and propose the TSB parameters. So in synchro, supports highway capacity model 2000 and 2010 methodology for synchronized intersection. We conduct corridor capacity analysis. We evaluate in synchro signal coordination and progression. And on the top of that, we can optimize the network. But in synchro has a little weakness, which is cannot model the exclusive bus lane. So after we finish synchro, we have to do micro simulation modeling using software packages, which is IMSON, and they have also VISM in the market. We finished calibration validation, and that model match real world operations. So everything in the field matches on the model. So in simulation input in IMSON, we built links and nodes, lane assignment, as you see in the pictures from the model, turns and volumes, crosswalk, signal timing plans, and public transit. So we built everything on the model, and that would take long time, a long process. So the advantage and disadvantage from this process, the benefit, of course, we have network level operations. The disadvantage is long process, as I mentioned before. So now I'm going to talk about TSB architecture. In this diagram, we can simulate how the central TSB deployment. So that's typical intersections. We have TSB check-in detector, TSB check-out detector, bus, TSB capable bus, has GPS. The bus, when approach to the intersections, connect with MTA Transit Center TSB server through 4G and request TSB. Now, MTA Transit Center TSB server communicate with New York City DOT TMC TSB server for TSB request. So once receive the message, TSB server send OK to MTA TSB server. Now TSB at TMC communicate with NiceWin network and communicate to traffic signal controller. And now the traffic signal controller knows what gonna do. Once the TSB granted, the bus leave the intersection, and that's all process done within 2 seconds. Back to 2013, New York City sub-regional ITS architectures, final ITS architecture documents. We built TSB system engineering on this edition. So in this diagram, a portion of the New York City sub-regional ITS architecture covered by the transit signal priority projects, transit vehicle and traffic. Transit and roadway subsystems are highlighted in yellow. Project System Engineering Analysis Report was completed back to January 2015. In that report, the Transit Signal Priority Project incorporates a new intelligent transportation system service into the New York City sub-regional ITS architectures. This service, known in the national ITS architectures as Advanced Public Transportation System, Transit Signal Priority, APTS-09 package. The new TSB package was integrated into the architectures with the existing Advanced Public Transportation System, Transit Vehicle Tracking, ABTS-01, and Advanced Traffic Management System, Traffic Signal Control, ETMS-03 service packages. These slides show the cover page of the Project System Engineering Analysis Report. It's free online, you can download it. It's about 62 pages and has a lot of good information. I recommend it, everyone can download it and read it. So after we implemented multiple routes, as of today, we have almost close to 1,500 intersections citywide enabled with TSB. So we have to maintain and make sure the system is working. So in next couple slides, we're going to show different kind of reports and how we maintain the system. Okay, in this slide, we're going to talk about once TSB parameters are determined by New York City DOT, we have to configure 3 systems here. Central Management Software, CMS, over New York City MTA, Traffic Control System, TCS, over New York City DOT, and standalone system, TSB SQL database. So the 2 systems, TCS and CMS, has to be configured with TSB parameters. So TCS manages to connect with traffic controller, and traffic controller knows what do with TSP parameters. The CMS file installed down MTA, also downloaded into their buses, and also they know what they do. With this system, we have TSB SQL database, which is collect reports from CMS and from TCS. The purpose was TSB SQL database to generate some kind of reports and found any issues or errors in the system. So the purpose for this management, we make sure is it working, how is it performing, identify any issues and flag the issues, determine any problem with the buses, intersection or TSB settings, make necessary adjustments either on TSB parameters or any issues buses or intersections. So checking the system, we evaluated process here. Start with system-wide, communication and hardware, route corridor level, bus level, intersection and signal control level. That's the steps we have to go. In these slides, we show how we were monitoring TSB at workstation. So system-wide TSB monitoring, ongoing communications, we generate some reports, performance. We have also live video feeds, as you see from upper right side, weekly report by Borough, real-time passenger information RTBI, and also we have sign map layers on the TCS. On the lower right side of the slides, we have different kind of reports. It starts from communication and performance. And these slides include update assets interfaces added for both transit and traffic sides, adopt software-based fleet and download TSB parameter within half day for a quick deployment, new interface to send TSB parameter electronic to New York City Transit, central system collects data for before and after studies, increase network bandwidths between New York City Transit and New York City DOT, TMC, to enhance transmissions. In this slide, the first example, travel time reports calculated based on the available data, travel speed, and also projected travel time from the first to the last TSB locations. And this slides example for automated TSB reports MOE. So as you see from the pictures, travel time summary, also signal timing display shows request, update, and clear messages during each timing cycle. On the right side, TSB green time calculation for each cycle. This is another example for automated TSB reports MOE. So in this slides shows TSB trigger point data exchange mechanism between New York City DOT TSB parameters generator on left side, and on the right side New York City Transit server when we implement new TSB corridor deployments, update existing corridor parameters, and how the system communicate between New York City Transit and New York City DOT at TMC. In this slides, it shows samples of TSB before and after studies. We have here about 5-6 corridors in 15 southbound and northbound. What's improvement between AM and midday and PM. And also we have S79 SBS between Brooklyn to Staten Island. That's about 15 miles. And also shows a improvement. We have also in Brooklyn B44 SBS and BX41 in Bronx. So TSB before compared to before study and after studies, we have in general positive result with the bus travel time improvement between 5 to 30% and between 10 to 30% faster bus speeds, about 10% increase in ridership, customer satisfaction about 95%. So with this looking ahead, what's next? We have right now we have application based TSB on every mostly New York City buses. We continue early action TSB, deploy TSB within a few months, much quicker than full analysis, which is take a long time. And for future, we are looking for near real-time TSB corridors dashboard. So the benefit with this system will show operational status of each corridors, and also will allow us quicker troubleshooting for any problem, any issues, and solve it immediately. So in this slides, we have about close to 600 intersection. That's we did implemented TSB through full analysis, and the blue color shows existing corridors. Ongoing corridors we have still ongoing red color. That was full analysis. That again cover 5 boroughs in New York City. In these slides, we have TSB area actions, corridors. As you see, different routes, different borough. Finally, these additional area actions corridors, TSB, that's again a different borough, Brooklyn, Queens, Bronx, and Staten Island. With that, I finished my presentation. So I believe we have a Q&A sessions at the end. So thank you so much for listening and looking forward for any questions. Thank you.
Thank you, Imad. That was a great presentation. It's near and dear to me. SBS, I actually worked on the first few SBSs in the city on the planning side. And with that, we're at the Q&A portion where we're going to ask 3 questions. And yes, this is fantastic. We're able to address comments as they occur. It seems like a lot of folks could not hear all the questions, or they were set too quickly. So what we're going to do right now is we're going to post them onto the chat, and I'm going to ask Imad to read the first question to the group. Imad, the first question, and please read it slowly.
Hello. The first question is, what bus corridor segment was the first to use center-to-center TSB?
Repeat that question, please.
What bus corridor segment was the first to use center-to-center TSB?
Okay, great. What's the second question?
The second question is, what does the active TSB scenario include in simulation modeling?
Please repeat it.
What does the active TSB scenarios include in simulation modeling?
Okay. Okay, and finally, and the last question.
What service package did the 2015 in New York City TSB project system engineering analysis reports add to the New York City sub-regional ITS architecture?
I can't understand why anybody didn't. I'm kidding. That was a long question. Just repeat it again, and we're going to post it in a moment on YouTube.
What service package did the 2015 New York City TSB project system engineering analysis reports add to the NYC sub-regional ITS architectures?
Great. And Imad, you're going to post it, right?
Yes.
Okay, great,
Yes.
Great. Fantastic. So that concludes our second presentation of the morning from our first session. And now we're going to go back to the studio to introduce the next presenter. The next presenter and presentation is, what is a smart city in Orlando? It means getting future ready. I want to introduce you Curtis Ostradaga, Director of Community Planning at VHB. With that, we're going to go right into the presentation, and hope you enjoy it, and stay tuned for the Q&A at the end of the presentation.
Good morning, everyone. My name is Curtis Ostradaga, and I lead the Planning and Design Studio for VHB's Orlando office. I'm very excited to be here with you this morning to tell you about a project we recently completed for the city of Orlando. You may have visited Orlando as one of our 70+ million visitors to see our theme parks and our beautiful natural resources. But there's a whole other side of Orlando that we are excited to share with you today. In 2007, Orlando Mayor Buddy Dyer created the GreenWorks Orlando program, an initiative to make the city one of the most sustainable communities in the country. Fast forward to 2016, where the city had a desire to integrate transportation technology and innovation and apply for a US DOT Smart Cities Challenge grant. While the city was just outside of the top 8 finalists, it used it as a springboard for its future efforts. The city and its transportation agency partners then created the Central Florida Automated Vehicle Partnership and applied and won a Smart Cities Council Readiness Grant. These efforts then led to being designated by the US DOT as a proving ground for automated vehicles. These continued efforts and partnerships led to several other grant awards for transportation-related facilities. However, the city wanted to look at smart cities and being future-ready beyond just the lens of transportation and apply it to other areas of community building, such as water, wastewater, and energy. So what is a future-ready city? In our review and research of other peer smart cities, there were a lot of interesting lessons learned and experience to be gained. One of the first things we saw is that some of the original smart cities were really technology-led and city procured. So in other words, a technology company would approach a community and offer them free technology, but there was not perhaps a really good reason to put it in other than that technology company wanted to pilot test things or get user data. As a future-ready city, Orlando is committed to a citizen-led process rather than a vendor or technology-led process. This means that the city is defining the issues and challenges that it's facing, and it's asking technology companies to provide solutions that are customized or specific for those Orlando issues. First, we had to ask all of our interdepartments within the city, what do they consider success? How do we think of ourselves as a future-ready city? And these word cloud exercises we conducted in individual department meetings all tell you a little bit about what the different business and values are for each community. So the bottom left is the police department, and you can see the word sensors got quite a few responses there because the department wanted to have that early warning when there's problems. On the bottom right, you can see that was our meeting with the Parks Department, where things like equitable access and fun at parks and recreational facilities was the most important driver to them. So understanding that all of these departments have different interests, Next, we combined all the department work clouds together in order to identify the common themes and overarching issues that the entire city wanted to see addressed as part of the Future Ready City Master Plan. You can see some of the large words that pop out, such as inclusive, connected, resilient, sustainable. These are all of the key drivers that we use to create a Future Ready Master Plan that benefits all citizens and visitors within the city. We used the discussions from the internal department meetings to create both a vision statement and a mission statement, both of which are broad enough to allow for flexibility for changing conditions as the plan evolved. The Future Ready City Master Plan is built upon 7 different pillar focus areas or topics for study. The first one is connectivity, where we looked at how we can reduce the digital divide between citizens who lack broadband internet and those that do. Energy relates to how we can include more renewable and clean energy sources within municipal operations and also encourage it for residential and commercial development. Health and safety examines how we can improve transportation safety conditions, mental health conditions, as well as homelessness throughout the city. It also looks at how we can improve safety and information for first responders. Mobility, a big topic of this conference, looks at how the city can prepare for new technologies such as autonomous vehicles and even electric vertical and takeoff landing possibilities for the future. Placemaking looks at how we can use technology, culture, and art to create great public spaces that improve the quality of life for all of these citizens and visitors. Materials looks at solid waste, food waste, and also recycling potential and how to make that more efficient. And finally, water looks at both water resources and wastewater including items such as wastewater-based epidemiology for COVID. As I mentioned before, the city wanted to make sure that the community engagement process was equitable and brought as many voices to the table as possible. This started with future-ready internal task force meetings comprised of city department leaders to look at the big picture of how the recommendations could be worked into the city's budget. Next, we had the internal city stakeholder interviews, which you saw already in the word clouds by the departments. This allowed us to understand what the opportunities and challenges are for each city department and break down some of the barriers that prevented work from being done a little bit more efficiently. We had focus area roundtable meetings for those 7 different focus areas that I showed on the previous slide. This is where we brought together subject matter experts from academia, nonprofits, other governments, and private sector consultants to look at each of those individual focus areas in great depth, identify the biggest challenges that they saw that the city faced, as well as prioritizing what they believe the top strategies and solutions would be to solve those problems. We held public workshops throughout the entire city, including a virtual public workshop at the end of the project when we were under COVID restrictions. We supplemented this with online surveys, again, to give as many people as possible a chance to participate. And finally, we've presented the plan to City Council. This is an example of a roundtable meeting where we brought together subject matter experts across the city to address a specific pillar focus area. In this case, the participants are looking at the mobility focus area to identify the biggest challenges they think the city will face in the near future, as well as prioritize what they think the best ways to address those problems will be through new innovative strategies and solutions. So one of the benefits of having individual roundtable meetings for each of the 7 focus areas was to see not only the unique ideas that came out of them, but identifying the overlapping and shared challenges that are faced by all members of the public, whether you're a resident, a visitor, or a business owner. Across the board, we saw a concern about the consumption of natural resources, about housing affordability and accessibility, which is tied to transit accessibility, and then maybe most importantly, access to the internet, what is known as the digital divide, which became so much more important once we went to remote work and remote learning. After the roundtable meetings, we started a series of community public workshops, and one of the first things we had to do was educate the public on the transportation technology investments that the city had already made. So as you can see on these boards here, the city has already started to invest in live feed bus stops, bike and scooter sharing programs, and other technology solutions for parking. And the green dots you start to see appear indicate if a member of the public liked this idea and wanted to see more of it across the city. Again, here are the potential strategies that were considered. And as you can see, there are certain clusters that begin to develop. And that gave us, the planning team, an idea of what, again, the priorities are for the community. People got so excited by this exercise, they started to write in their own ideas, which you can see on the sticky notes there. And then other citizens would read those sticky notes and put dots on them as well. So it was a really grassroots driven process where the community was either confirming an idea that was prepared by the roundtable subject matter experts, or confirming and prioritizing the ideas that their fellow citizens had created. So this page here summarizes the roadmap or process we went through for the Future Ready City Master Plan. The top line shows how we brought the community together to identify challenges and community-supported solutions, as shown through their dot voting. The next step was to take all of those ideas, of which there were hundreds, and prioritize them into actual strategies, because we wanted to create an actual working plan that had operational analyses and evaluated the constraints, the costs, the return on investments, So we needed to run this through a prioritization matrix in order to come up with a plan that would be implementable and feasible. The public engagement process yielded over 100 different ideas for how to include innovation and technology into city processes, but we needed a way to prioritize the best and most implementable ideas so that we could create a working plan that would have a capital funding back and schedule to it. So we created an evaluation and prioritization process that looked at 16 different elements. For example, if a potential strategy would address multiple pillars such as energy, placemaking, and mobility at the same time, that could receive priority over others that only addressed single pillars. We also looked to make sure that the strategies were future ready and could address the needs of the community. What we were not looking for was a new technology that was in search of a problem. We wanted to address the specific ideas and concerns that were identified by our community members and make sure that it met the long-term vision of Orlando. We also wanted to see how we could align with our regional partners, so how they could provide funding or in-kind support. We wanted to make sure that all the strategies would be effective for at least 5 years. And if there were out-of-the-box solutions, that would be a good place to get started. And most importantly, we wanted to make sure that the strategies benefited all of Orlando. So we wanted to make sure it wasn't just beneficial to folks that already own a smartphone, but rather how can this also benefit vulnerable communities within the city. The other criteria of the evaluation matrix were heavily weighed upon how easy it is to implement a strategy. We looked for strategies that could be implemented in less than 2 years in order to find that low-hanging fruit that could make an immediate impact. We also looked at the visibility with the public. Would this be something that the public had previously indicated their support on, or would it take additional resources to interest them? We looked at existing resources available to staff as well as funding sources available. Because the city wanted to start with pilot projects, we wanted to make sure that any new idea would be scalable, either up or down, in order to address larger parts of the city. We also looked at where our partner agencies were going to see if there were any leveraging capabilities with other area plans. And finally, we looked at the potential for local job creation and economic development within the city. So this is the list of short-term strategies that the plan prioritized across all 7 of the pillar focus areas. Some of them, like the digital twin, may encompass all of the different pillar focus areas, while others, like community Wi-Fi and addressing the digital divide, are mainly within the connectivity pillar focus area. I'm going to take a few moments next to talk about the mobility-related short-term strategies. The first short-term transportation strategy is called the Integrated Transportation Application. Sometimes this is known as mobility as a service, but the city didn't want to call it that because they were actually not providing the mobility solution. That was the city's partner, Lynx, the Central Florida Transit Association. So the idea here is to leverage the Florida State Department of Transportation's investment in what's called a route mode choice engine, which is a big data lake that provides transportation feeds for transit, for roadway conditions, for available parking, all in a unified interface. But the DOT application lacks a front-end user application or user interface. So the city would like to show leadership within its region to create that front-facing user interface or app for your smartphone that would allow citizens, as well as the 70+ million visitors we receive per year, to make smarter choices about their transportation modes and choices. And in order to address folks that may not have access to a smartphone, the city would like to install solar-powered kiosks in underserved and vulnerable communities also at bus stops and at City Hall. So people would, even without a smartphone, would be able to get access to the same trip planning software. It's also envisioned that this would support a single payment system, which is not currently available within the city. The second short-term strategy for transportation is called the Alternative Transportation Mobility Program. The city's already done a pilot project on this, where users downloaded an app that would provide them with reward points if they logged a trip to downtown using an alternative mode of transportation. So that could be walking, cycling, taking the bus, taking the train, or carpooling with somebody else. The platform also provides rewards for single car users in order to let them know that the possibilities are there to use alternative modes of transportation once or twice a week. So if you are able to accumulate enough points, then the app then provides a reward for, say, a downtown business. So a good use case study is if you ride Sunrail, which is our commuter train system, 5 times a week, then you may be able to get a $5 reward at a local business downtown. One of the most exciting short-term strategies is the creation of an electric vertical takeoff and landing, or eVTOL, regional plan. The city has already seen interest from a private developer, Lake Nona, to build a vertiport at their mixed-use community. So the city would like to be prepared for the next several vertiport applications that come in by creating a regional plan that can look at operations, airways, and the other constraints that need to be taken into account. The benefit of eVTOL is reduced congestion on the roads, and there is also the potential for transit-oriented development and economic benefits around the vertiport stations. The final transportation-related short-term solution is an expansion of the city's existing smart parking infrastructure. The city's already replaced most of the on-street parking meters with smart meters that accept credit cards, have occupancy sensors, and can be reloaded from a mobile phone. The next step is to replace the existing garage parking spaces with additional smart parking features. This would allow the city to provide priority or reserved parking spaces, which could then increase the revenue that's available for the city. Another benefit of this is to tie into a unified fare collection system in association with the integrated transportation application that we discussed previously. The benefit of this to the city would be to increase the quality of life of residents because they would have some assurance that a parking space will be available for them when they choose to commute by car downtown. This would remove a barrier and any unnecessary delays from circling or not having readily accessible parking. In addition to the short-term strategies that already have capital funding behind them, we identified a number of mid to long-term mobility strategies for the plan. Some of those include digital curb management, or a better way to manage all of the freight and TNC rideshare that is dependent on curbs, putting in a connected and autonomous vehicle downtown pilot project, perhaps along our existing bus rapid transit route, putting in increased electric vehicle fast charging infrastructure, something I'm personally interested in being a brand new EV owner, improving our intelligent transportation systems for better traffic optimization throughout the city, and then that elusive single payment platform for all forms of mobility, because right now we have separate forms of payment for bus, for train, and of course for parking. This concludes the presentation, but I'd be happy to connect with you offline to answer any follow-up questions. My contact information is shown below.
Curtis, great feedback. Great presentation. And now we're at the question and answer part of the presentation to get your PDHs. And with that, we're trying to improve this. I know we're getting a lot of comments online. So Curtis is going to say the first question, and he's going to post it on YouTube so you can respond to it. And so let's start with the first question.
Okay, thanks, Luigi. So I have posted the questions to the sidebar. The first one is a general question for you. How does a city or wherever it is that you happen to work in your region work with your agency partners in order to advance mobility overall as a region?
Okay, good.
Second question.
Second question.
Trying to keep these a little bit less wordy for you all. How do you address equity and the digital divide in transportation planning?
Perfect. You got the timing down. Ask the third question.
The third question is, why is it important to involve the community at the beginning of any of your projects?
Great. Before we go on, let me just see if there's any other questions. If anybody has any questions, just start asking right now. If not, hold them over for the panel discussion. Okay, that's fine. So let's go to our next. Let's go back to the studio and introduce our final presenter of the first session. And with that, next presentation is using data to manage a world-class airport terminal frontage. And I'd like to introduce the presenter, Michael Afazia. He's a principal engineer at the Port Authority of New York and New Jersey. And if you want to read his bio, it's online as part of this event. And with that, let's go right into the presentation.
As the availability of data and changes in technology change the transportation landscape, it is important to adapt infrastructure design to both keep it useful and take advantage of tools at the industry's disposal. As the Port Authority of New York and New Jersey embarks on redevelopment programs at all three of its major New York metropolitan area airports, we seek to build an airport terminal that provides a world-class customer experience and does it efficiently. I'll start today by giving you an overview of the Newark Airport redevelopment program. And then dive into the world-class customer experience and what that means for the design of the new terminal's frontage roadways. Lastly, I'll touch upon the data hub and our work to use data in airport operations, specifically some lessons learned from LaGuardia Airport. The Newark redevelopment program will completely replace the aging substandard Terminal A with a brand new 1 million square foot terminal, including a head house, which includes baggage claim, ticketing and security, and 3 concourses, the south, north, east, and west. Together, they will provide 33 new gates for domestic flights. The terminal will also be connected with a pedestrian bridge to the Newark AirTrain and a public parking facility. The new frontage roadways will provide a world-class, cutting-edge customer experience. The program will eventually replace Newark's aging AirTrain system with a new 21st century rail link. The program also includes a consolidated car rental facility across from the new terminal. Here you can see a picture of the new terminal under construction. This is the head house with ticketing and baggage claim and the 3 concourses. This will be the consolidated rental car facility and parking garage as well. Here you'll see the departures roadway already constructed, and the arrivals roadway will be directly underneath. That dotted line represents the future pedestrian connection between the Conrack parking facility and the new terminal. The new AirTrain station will be located immediately in front of the new terminal, providing direct access. The existing AirTrain ends just off to the left of the screen, and on opening day will provide connection to the new terminal through the parking garage. I've used the phrase world-class customer experience a few times already. What does this mean? In the age of the smartphone, today's traveler expects information to be readily available, intuitive, and personalized. They expect their journey to be predictable while not needing to plan out each step in advance. An airport operator must therefore look at each potential journey and be sure each touch point provides the necessary information and keeps the customer moving on to the next leg of their trip. So here's two such scenarios that we would look at. One where an arriving passenger is using a parking lot and making sure that the terminal wayfinding step by step gives them the information they need to get to the parking facility, and also gives them information on their expected arrival time to that facility and ultimately arrival time home. Scenario 2 looks at a customer who would use curbside transportation. So we may not only be directing this customer to a given mode, but also helping them choose that mode, giving them information on travel times for various modes or arrival times for trains or buses to help them make their decision about the best way back home or to their ultimate destination. The initial design for the new terminal at Newark Airport predates the overwhelming prominence of TNCs, transportation network companies, such as Uber and Lyft. It lumped the majority of pickups to a 4-lane section of roadway adjacent to the terminal with 2 active pickup lanes, which required double parking to meet the capacity needs of the terminal. This is what you can picture as your typical airport frontage, which many of us have experienced, where you stand on the curb on your tiptoes looking for your party and then have to dart between double parked vehicles to load into your vehicle. The outer roadways were used for taxis and HOVs or buses in this design. As the program moved forward, it became clear that the original design would not meet tomorrow's needs. The Port Authority researched successful frontage arrangements at other airports worldwide and reassessed our own needs based on the current transportation mode use at our own airports. The result was 2 dual-sided frontage roadways with single lanes of pickup on either side of each roadway. This increased the available curb space by 250% and put every pickup immediately along a curb. The new configuration also allowed for discrete loading zones, allowing dedicated curb space for given modes. The curb space closest to the terminal has been reserved for private occupancy vehicles, since those traditionally require loading on the right side of the vehicle, and this roadway is easily accessible from the main roadway approach to the terminal. A single lane makes it easier for customers to connect with their party. The dedicated taxi loading zone provides more curb space than is necessary for loading, and this allows a queue of taxis immediately upstream to the loading area to constantly feed a roller coaster style loading operation. Roller coaster style loading simply means that the head vehicles are all loaded concurrently. Once they're loaded, they all leave concurrently, and then those spaces are filled by the vehicles behind them. So you can picture like loading a roller coaster train, and it all leaves the station at the same time. Transportation network companies and other for-hire vehicles also will have dedicated pickup zones. Isolating particular modes or particular companies keeps the loading process orderly and narrows the scope of the drivers and passengers' search for each other. So picture, rather than searching an entire airport frontage, if you know you're solely looking in the Uber section for your Uber, that narrows your search and the number of vehicles you're looking through. We also continue to work closely with Uber and Lyft to further narrow that search through the use of pin dispatch and pre-dispatch technologies. The former, pin dispatch, works similarly to taxi loading, where a queue of passengers boards the next available vehicle. When the passenger then boards the vehicle, they give the driver a unique code, which then helps match the driver and the passenger in the application. pre-dispatch attempts to predict the demand at the curb so that a fleet of vehicles is ready for customers at the curb when they arrive. Unlike PIN, each customer is matched with a specific vehicle, but the notion is that there's always a vehicle there waiting, so that it minimizes the time a customer is actually standing on the curb. We are also looking to install digital kiosks along the frontage to assist passengers with finding their driver and their driver's loading zone. A dedicated curbside lane will also be provided for bus loading, and this provides ample room to spread the demand and delineate between different types of buses in different sections of the frontage. This shows you a cross-section of the future terminal frontage, hoping to provide an orderly pickup experience with clear delineation between the various modes. And that delineation is clear both for the drivers approaching the frontage and also for the passengers exiting the terminal and looking for their vehicle. You may have noticed that the past several slides were headlined flexible curb operations. While I walked through our current thinking of placement of specific modes, our goal is to keep the operation of the frontage as adaptable as possible. Just as 10 years ago, we did not foresee the prevalence of transportation network companies, we must foresee the unforeseeable and be ready to adapt to shifts in mode share or introduction of a new share in the future. Just about the only constraint that I can think of is that buses and personal occupancy vehicles do need to typically pick up on the right side of the roadway. However, other than that, our biggest hurdle really is typically a change in signing. So if we were to relocate an operation on one of our existing frontages, it would require fabrication and installation of hundreds of pedestrian signs directing folks to given areas of the frontage, and then also vehicular signs direct the vehicles to their section of the frontage. Now, with digital wayfinding and curbside signing, we will be able to change the frontage allocations based on our needs, not only wholesale, but also possibly temporarily to adjust to seasonality or to adjust to incidents on the roadway network or along the frontage itself. In order to make informed decisions about how to allocate the curbs, however, and to manage the operations, we need data. And the new frontages will also therefore contain pedestrian detection and data collection, traffic vehicle detection and data collection, Bluetooth beacons, and future connected and autonomous vehicle roadside units. Here you can see a diagram of the proposed DMS locations represented by those purple rectangles. So the rectangles that are parallel to the roadway represent the signs you will see exiting the building or crossing the crosswalks via the green arrows. So that will tell you which direction to turn once you're leaving the building. The signs that are perpendicular to the roadway, the smaller rectangles, then represent both pedestrian signs that kind of pull those passengers to their appropriate pickup zone, but also act as vehicular signing to draw the vehicle to their designated pickup area. So each zone between crosswalks will be identified for a specific user, but then having multiple signs for each zone also allows you to identify a more discrete pickup area so that can help match a driver and their customer. All of these signs, like I said, are fully programmable so that we can not only change it in the future for different curb allocations, but also based on an incident on our roadways or an incident on the frontage, which may require us to move a given user to a different section of roadway. Another example may be if there's an air train shutdown and those buses need to take up a section of frontage. This allows us to relocate users easily and direct those customers easily. Here's a location for digital kiosks. So these kiosks can help provide real-time information for transit and taxis and TNCs. That may be arrival time for the next bus, it may be arrival time for a personalized TNC, a loading zone for your personal TNC, taxi wait time. It may also provide you cost for these modes to help you make an informed decision about the best way to get to your destination. This map shows the potential location for pedestrian and traffic vehicle detection. These will give us situational awareness of things like vehicle dwell time, and pedestrian dwell time or pedestrian density can help us identify a problem and make operational changes based on that problem. Can both do this real time to identify an incident. Maybe we see a large taxi queue and therefore know we need to dispatch more taxis. But also for future planning as a new mode comes into the marketplace, or if mode share is shifting, we can see that using the data from these and leverage that to plan operational changes at this terminal and also future terminals, future terminal 2, for example. This shows the proposed location for Bluetooth beacons. These Bluetooth beacons can provide personalized traveler information for a mobile application, including push notifications for things like a incident on a local roadway, or perhaps there's a airport incident or operational change that we need to communicate to users rapidly. These also help in GPS positioning for our TNC customers, both for the vehicle and for the passenger, and having those GPS coordinates displayed more accurately also assists in pairing the driver with their passenger. We're also looking to future-proof by installing the infrastructure for connected vehicle roadside units. And these could potentially communicate from the airport to CAVs to identify the best area to pick up their customer. Here is one final rendering of that future airport frontage. You can see the DMS here along the frontage, identifying the pickup zones. So now we have devices installed along our terminal frontage, but what do we do with this data? How do we make it useful? The data from all of these devices is fed into a centralized data hub. This hub allows data from various sources to be leveraged through the use of dashboards for real-time operational decision-making. The data goes beyond that collected from the devices we've already discussed. It also leverages vehicle detection data from around the airport or on the roadways approaching the airport, and as well as data from our terminal operators and airlines, which can all help us predict roadway conditions and make operational decisions. ATMS, our agency-wide transportation management system, is used to monitor and operate all of our intelligent transportation systems. And ATMS contains preset scenarios that can be used by facility operators based on specific observed conditions. More broadly, this data can be used to analyze trends and plan for future events or designs as well. Or if there is an incident, can help in after-action discussions to help better performance for another future incident. The Data Hub was born of necessity during the LaGuardia redevelopment program. It quickly became clear during LaGuardia's reconstruction that it was necessary to really micromanage the roadway network to keep traffic moving during construction and get customers into and out of the airport in a timely manner. This is an example on the right side of the screen of a real-time dashboard that is used by the LaGuardia Airport Operations Center, LaGuardia AOC, to monitor roadway conditions and expected passenger volumes. This pulls data from a variety of sources, the airlines, here mapping platform, as well as our own on-airport devices, to make quick data-driven decisions. Between that data and the eyes that the AOC has on the roadways via our cameras, we can be alerted to issues, able to identify the cause of an issue, and then monitor the success of mitigations and clearance of those incidents. The local airport operations center is just one piece of the puzzle, however. The agency operations center, conveniently with the same acronym, serves as the link between the facility, the communication platforms, mapping applications, and our sister transportation agencies. The agency's relationships with the mapping platforms has been particularly useful in communicating closures and changes to our roadway network and helping our customers prepare for their journey. So not only were we able to very quickly get new roadway alignments in those mapping applications, but also for major changes, we were able to send push notifications to drivers that typically use that roadway or along that roadway. Just another example of getting personalized and useful information to our customers through technology, help us achieve that world-class customer experience of a 21st century airport. And thank you very much.
Michael, great presentation, and having worked on some of those components, I can attest on how successful it's been on LaGuardia and now moving over to Newark Airport. So let's start off with the three questions. Again, Michael is going to ask the question, and then he's going to post it on YouTube. And if you have additional questions, just post them. So Michael, let's go with the first question.
Make it easy for you guys to answer. They're multiple choice. First question is, how much did the new arrivals curb layout increase the curb space at Newark's future Terminal 1? A, 50%, B, 100%, C, 200%, or D, 250%? Question
Great.
2.
Let's go. Yeah, let's go with the next question.
Okay.
Yeah.
What intelligent transportation systems contribute to the operation of the flexible use frontage? A, dynamic message signs, B, video vehicle detection, C, video pedestrian detection, or D, all of the above?
Okay.
All right.
Wow, you're getting. By the way, you're getting the best set of responses.
That one I had trouble.
I think next time for the other presenters, we're going to go definitely multiple choice.
And I had trouble pasting that one. I'll paste 2 and 3 when I'm done speaking. Question 3. Traffic engineering stores all of its data in one centralized database called A, ATMS, B, AOC, C, Data Hub, D, JTMC.
Oh wow! Excellent. Good feedback. All right. That's the last question, Michael, correct?
Yep.
Great. Thank you for the presentation. I know we said that there was going to be a 10-minute break, and then we're going to go right into the panel. We're going to take a 1-minute break. We're just going to barrel through the conference so we can end a little bit early. So we're going to take a 1-minute break just to set up the panel, and then we're going to restart. So I'll give you a 1 minute break. I'm going to post the front cover of the promotional. I'm going to play a promotional video as we set up. Well, actually, I can't do that. So, anyways, in fact, we're going to start the panel now. I just realized we can't do that. So, give me 1 second. I'm going to get the other panels in here. So, I'm going to shut some people down here. Okay, so excellent. Imad, Paul, can you open up your screens? Excellent. Imad, are you there? Just give us 1 second. Imad, if you could open up your screen. Just do a little sound check. Kurt, are you there?
Yes, sir.
Perfect. Mohammed?
Yes.
Michael?
Yep.
Paul?
Here.
Imad? All right, so as Imad gets back online in a second, I'll start off with the first set of questions for this amazing panel. Where we talked about a lot about technology, and one of the things I'm sure a lot of young folks out there, the common theme throughout this entire presentation has been, data-driven, information and coming up with solutions, and that's been the theme across all the presentations. And I'm going to ask each one of you, what advice would you give a young engineer beginning in their career to get into, transportation, and what they should be doing to better prepare themselves for the future? So I'll start off from the left, Kurt, and then we'll go Mohammed, Michael, Paul, and to Imad. So, Kurt.
Sure, I would read as much as you can. Read technical journals, read tech blogs. Just be aware of all of the new innovation and technology that's coming online. Odds are that the folks that are like me, that are starting to get a little gray in their beard, aren't going to be keeping up with all the new trends like the young folks coming out of school. So just read as much as you can.
Mohammed?
Yeah, I think it's important to keep up with the new stuff. Like, for example, after you finish your degree, you already know some information. But if you only depend on that without keeping up with what comes out every year, you will be falling behind. So, yeah, my advice is that even if you're young and even if you just finished your degree, always check the new stuff that come up every year.
Michael?
Yeah, I think we have a lot of people that are experts in data science and a lot of people that are experts in transportation, but finding that person that knows both is kind of a unicorn. So I think if this is a field that interests you, learning data, but learning how to apply it to transportation and making sure you have knowledge of transportation operations as well will really benefit your career.
And Paul?
Traditionally, the field of transportation engineering was dominated by civil engineers, so on and so forth. I think with the new technologies we're seeing there's a bit of a transition towards, the types of expertise that you need getting into this industry. Not to say that the civil engineering domain isn't important anymore, but I think more and more we're seeing the need for skills in computer science, electrical engineering, with automated vehicles and ITS equipment. It's becoming a lot more data-driven, and I think those skills are being in greater demand than ever.
Great. And Imad?
Yeah, hi. What I recommend for new graduate students, first they have to follow ITE website. They have a lot of webinars and a lot of good presentation. They can attend those presentations and understand what's technology about. Today, the technology is very fast, and they have to follow technology as much as they can. And yeah, and you can check also kind of training online. ITE also website has a great program is leadership ITE. They can take it later after a couple of years, and that's very helpful. They can have connection nationwide. I think that's all my advice at this time.
Great, great. So I'm going to continue asking questions. I'm monitoring the YouTube chat. So if anybody has questions, please ask them, and I will ask the presenters, and they'll actually see themselves. So one of the things I'm going to ask Paul and Mohammed is, in safety analysis, there's always been difficult getting good data before and after, and how you monitor it, and what the impacts are that improvement that you made. Do you think this technology will make it possible to make crash analysis obsolete? So, what are your thoughts on that?
I can start with that. Definitely, at least in the short term and the medium term, we're not looking necessarily to disrupt the traditional approaches to road safety analysis. We're looking mostly to complement the shortcomings, especially when we're talking about dealing with gaps in road safety data, but also complementing with additional information. So, when we have video evidence of situations even before the crashes happen, we can kind of dive in and look at the mechanisms. This sort of the mechanisms of the crash, the sort of information you wouldn't typically get from, let's say, a police report, because the police officer doesn't know, what the traffic engineers may be looking for in terms of making modifications to the road. There's just not that kind of training. So there's definitely benefits there, and it's complementing. Long term, really, I don't know. It could go a lot of different ways. Mo, do you have any other comments there?
I totally agree with that. Like, it's difficult to know what will happen long term, but I think short term, like, this is a very interesting field and potentially can provide more information that we currently have from the regular crash data. Yeah.
Oh, thank you. I have yet to see a question on the channel, so I'll go to the next question. And this is, Michael, I'll start you off, and if anybody else wants to chime in, and this is a question I'll ask for both panels. In the age of COVID, you know how difficult it's been with all this data. What challenges do you foresee moving forward that, COVID, in this age of COVID, using technology, has it forced you to think differently, approach projects differently, and is that going to change after COVID? So, Michael, you can start off, and anybody wants to chime in, just let me know.
Sure. I think working in an airport environment, there aren't many opportunities from our current pandemic, but being able to progress an airport project quickly is one of them. So we've been able to, take sections of roadway that we wouldn't normally be able to take just because of the low volume. I think we've had to adapt our data inputs and what we're reporting, where we were looking for kind of congested peaks before to be able to handle operations. Now we're looking at longer term trends to see how the airport is recovering, how passenger volumes are recovering, but also as people return to flying, are their choices changing? Are they taking different modes of transportation than they used to? So I think it is making us kind of focus on different data points than we were previously.
Anybody else want to chime in?
One of the things we're doing is with COVID and everybody working remotely, and especially having students that are doing remote learning, the city has partnered with T-Mobile to put out loaner hotspots and mobile tablets at the community centers, so that the students that are not able to be in school can check those out, and then be able to do their schoolwork at home. So it hasn't really changed our commuting pattern, but it's a strategy we're using to bridge the digital divide. We're also putting them at senior centers to improve digital literacy of seniors. And we preloaded, resources for jobs and resume building to try to get folks back into the workforce.
Any other questions? 'Cause I actually did get a question online. I'm going to read it out right now. And this actually is directed to Michael. What training and supervision will be provided to airport monitors who regulate the vehicle parking, vehicle picking up passengers from a safety and efficiency standpoint? Michael, I don't know if you saw the question online.
No, I didn't.
And I can repeat it if you. Okay.
No, I think I understand the question. I think that it is difficult to make sure that those bodies on our airport frontages are working effectively. It is a combination of our own police force, airline employees, and other airport staff. So I think the best thing we can do is communicate with them in real time. So using LaGuardia as an example, our airport operations center has traffic engineering operators who have real-time communication with those folks on the frontage, and also have eyes on the frontage through our cameras. So it's kind of taking the decision making off of those people on the frontage and providing input from experts in the AOC.
Okay, good. That's the only question so far online. I'll go to the next question. This is directed to you, Imad. And having worked in city many times, there's a lot of double parking on those SBS bus lanes. And I know that the city has implemented enforcement cameras. Curious to know, and I'm sure a lot of people are curious, has it had an impact on reducing double parking and parking in those lanes to increase travel time reliability for all those buses?
So let me start with right now, New York City DOT is committed to working with the MTA and NYPD on that part to improve buses citywide. So part of this program, we have something called the Better Buses Action Plan. It's focused to improving bus speed citywide by 25%, increase cameras, and NYPD enforcement of the bus lane. In addition, we have to improve every year. We improve 15 to install new bus lane between 10 to 15 miles, and also improve the existing bus lane every year as well. So with my experience with camera enforcement and NYPD, it is working, but we need to make sure to monitor that at TMC, and also the issue of violation immediately to the violation wherever they using bus lane. Yeah, of course, the bus lane sometimes double parking, especially on the commercial area. People has no to use the bus lane, but again, the bus lane sometimes is open between 7 a.m. to 7 a.m. to 10 a.m. and during the midday sometimes it's anybody can use it. Depends on the locations and the routes. And PM same thing. For example, Highland Boulevard, bus lane going to Verrazano Bridge in AM is open between, I believe, 7 a.m. to 10 a.m. Going back from Verrazano in PM, it's bus lane can use it between 4 p.m. to 7 p.m. So that's every year the New York City DOT install more buses, but again, more cameras. But again, that depends on grants from the federal, and it needs a lot of efforts to apply for that. And yes, it's working.
Excellent. Just saw a online question, and this is directed to Paul Mohammed. How close do vehicles have to get for it to be considered a near miss?
I guess I can take that one. So we don't measure the closeness or the proximity in terms of distance, because if you stand next to a parked car, or if you're walking next to a cyclist, who's traveling at a very slow speed, it's not inherently dangerous. So what we're looking for is a closeness in terms of time, time to collision, because that tells us, based on what we know about human reaction time and the time it takes to avoid a collision course. Knowing that information, we can estimate what are the chances that interaction results in a collision. So typically we'll be using about 1.5 seconds of reaction time. That's what has been measured in the lab in terms of reaction time to avoid a potential collision.
Great. Okay, I'm still monitoring. I don't see any other questions. This is gonna be the last question if nobody else asks any questions. And this one actually goes to Curtis. What about this pandemic? What makes your sports team so competitive? To what extent did the Orlando Smart Cities help nearby Tampa Bay win a Stanley Cup and a Super Bowl within months, and almost a pennant?
Well, I'd like to think we had a great impact on helping Tampa's economy. I'm actually grew up in Chicago, so I don't really follow the Florida sports as closely, but we're happy for the state's economy, especially since we are such a service-based industry still. We're excited for any opportunities for that kind of economic development. But I think we've got a lot of great opportunities with the Brightline connection. This is a high-speed rail connection between Orlando and Tampa to further strengthen our regional transportation connections. Florida is still a very young, growing state. It's not nearly as dense as the New York, New Jersey region, so we still have a ways to go in our infrastructure. But this could be a great way for us to bridge that gap and improve overall connectivity.
Great. And now we just delayed it enough time for somebody to ask a question. Kurt, how closely does the city work with private corporations such as Disney in connecting smart mobility systems between the central business district and private campuses? Did I get that right? Yeah.
Okay, I'm rereading that on the chat. So if you've visited one of our theme parks, you probably know that there are massive parking fields. So just about everybody that comes in pays $20 a day for a parking space. So I think the previous mode of thinking was not to encourage ride sharing or transit unless it was transit within the parks, going from one park to another after you'd already parked your car. I do believe that the theme parks are starting to get more progressive in terms of how people would like to travel. So there are advanced discussions with the Brightline private train system, high-speed train system I mentioned, for transit stations and multimodal hubs within those theme parks. So that's exciting to see because it gives people another way to get around, takes some of the load off of our congested roadways, and improves our environmental health, which is a great thing.
Fantastic. Another question. What does the traffic surveillance cost, and is it a standalone that the data needs to be retrieved from the field, or does it need to use a central computer system? I think that question probably goes to Paul and Mohammed, and if anybody else wants to chime in. Have you seen the question online? It's from Brian O'Rourke.
Yeah, I see it. For cost, I mean, it'll depend a lot of things, and we can set you up with a sales rep to talk about pricing structures and so on and so forth. Mo, do you want to tackle the second part?
Sure. So we have two options. Like one is using pre-recorded videos. Like usually the clients would have recorded like few hours or few days of footage from a specific site of interest they have, and then we process that. That's like the majority of the projects we have, but we also have another one that can do analysis like 24/7 continuously. And that one would usually use a server or like a computer installed at the site. It would like record the stream continuously, and then we process it on the server, and then we compile and generate the results.
Yeah, I know this was directed to the collision cameras, but also I'm very familiar with the Port Authority is doing, and that is definitely something, Michael, maybe you won't even want to chime in, but there's a lot of cloud computing and a whole bunch of other things you need to consider regarding data collection, processing, and getting it to the users. So if there's anybody else that wants to chime in on that question. Okay. If there's no more questions, we're going to conclude our first panel. And unfortunately, I don't have an applause track or a clapping track, which I will have for the next event that we ever have. So first panel, Imad, Paul, Kurt, Mohammed, Michael, thank you. Fantastic panel, fantastic information. We learned a lot. Before we go to our next session, because we're not taking a break, I just want to remind everybody, after the presentation, there's going to be an email link that's going to be sent to you to retrieve your PDHs. So you got I forgot to mention this at the beginning. You're going to have to log into the ITE website, answer a bunch of questions, and they will email you a certificate. I'm sure everybody's going to want that certificate, especially for those of you who have PEs and PTOEs. So with that, let's go back into the studio and start our second session.
Thank you, Luigi.
Thank you.
Thank you.
Thanks, Luigi.
So the next session is going to be dedicated to parking, then, now, and into the future. With that, we have our first presenter, Gordon Meth. He's a transportation expert at Robson Forensics. And I don't think he really needs an introduction. He's been around IT. He's been former past president of IT on the national boards, and you can look at his bio. And with that, let's go right into his presentation.
Good morning, everyone. My name is Gordon Meth. I've been a traffic engineer conducting traffic and parking studies in suburban locations for nearly 30 years. And within that, I've spent a lot of time really debating whether sites have enough parking or not. One of the bottom lines of this whole presentation is this: how long are we stuck? Do we become stuck with old standards? And when is it time to really renew them and look at them? With that being said, I've spent some time really looking at parking data. So, starting at the beginning. So modern development, to the best extent we can, utilizes modern planning and design principles: smart growth, complete streets, sustainable transportation. The bottom line is we've been trying to make our sites more compatible with our environment and climate change and people living versus the way they've been for some time. Parking still remains a necessary and important feature of modern development. We still deal with it. As long as we still have our own vehicles, we're going to have to keep going with that. The key, in many respects, is for us to adopt smarter parking principles in planning and design. That's really the ultimate goal of what the next stage is. Now, how big a deal is parking? Well, parking can take up a whole lot of a modern development. I admittedly, in New York City and other places, they've taken on the principle of shared parking facilities and really removed the parking from the individual site, at least in Manhattan. Maybe not necessarily in all places, but in more of a business district. I had a former boss once who said to me who said that or he used to love saying that if we followed level of service standards the way we do on traffic impact studies, we never would have gotten Manhattan. So that's an important lesson to think about when you talk about a sense of, how parking fits into that. So off-street parking requirements. Off-street parking requirements really started to address concerns about parking from various specific land uses using too much available on-street parking. So in response to that, municipalities across the country began requiring off-street parking to be incorporated in development. And over time, that's expanded and grown. The number of parking spaces required by these ordinances have often been based on data collected in the ITE, or the Institute of Transportation Engineers, Parking Generation Manual, either directly or via other publications. So the key is the data has to come from somewhere, and it keeps getting expanded and grown and advances from there. One publication I can recommend, which is a great read, is a publication by Donald Shoup called "The High Cost of Free Parking." And this gets heavily into some of these issues. So one of the landmark books in the establishment of parking requirements was a publication called Parking by Wenton Levinson, published by the Eno Foundation about 1990 or 1991. That publication utilized the 85th percentile parking demand and then added about 10% for recommended parking standards for various land uses. Now, let's step back a second and talk about what 85th percentile is. So this may be familiar to many of you who are traffic engineers, but maybe not everybody. The bottom line is that comes from statistics. Oftentimes, we find that patterns of data samples follow a normal distribution pattern. And within that, the median is the middle. That's where half the sites or half the samples are up below and half are above. We also look at standard deviations, and the first standard deviation in either direction usually contains 34% of the data samples. So when you have what's known as a two-tailed test, meaning you're going from the median outwards, the one standard deviation can get you 68% of samples. But if you're only going to a one-tail test, meaning a line at which everybody is at or below, you got to go to the median plus one standard deviation. The first one's 84%. People round it up to 85th percentile. And what all it means is that that's the number at which 85% of the samples are at or below. The theory being we can't design enough parking for every single sample, but we want to at least take into account the majority, the vast majority of them. Previously, prior to current times, we've used the similar philosophy for setting speed limits. The strategy makes sense, and since if one used the average parking rate or the median, theoretically half of all sites would be underparked, and that's part of the problem. Now bear in mind that when we look at this and we look at parking, we're often looking at every individual site in isolation as a single entity. And therefore, we do have to worry about not being stuck with half the sites not working. When we deal with traffic and like trip generation, and we put all our traffic from individual sites onto the road, we usually there deal with the median rate for the simple reason, or the average rate, for the simple reason that the highs will outweigh the lows and we'll get regression to the median or the average. So many ordinances also require enough parking for each individual use at a site. So let's take, for instance, a mixed-use development. Let's say you have a very large site with an office building, a apartment building, and a shopping center, a small shopping center. Well, in many ordinances, if they don't recognize the concept of shared parking, would require a separate amount of parking for every one of those uses, instead of letting everybody share the parking and as a shared commodity. And I'll also tell you that assigning parking spaces is inefficient. That is a problem. But the theory of having each individual site have to provide its own parking does that. So the result is that many parking spaces go unutilized most of the time, at great cost to the public. Land use development patterns make transit, walking, and bicycling more difficult than necessary due to the need to cross big parking lots to access buildings. Potential on-street parking spaces go unused. That's the other part of this, if everybody provides their own off-site parking. And we have to treat far more stormwater due to the additional impervious surfaces. We create more of a heat island. We create more environmental degradation because of the need to provide so much parking. Older buildings that are closed to many potential uses due to a lack of available parking, they're closed off. So older areas remain blighted. So the key is, let's say you have an old neighborhood that doesn't have off-street parking lots, in an old downtown, for instance. Well, all the new uses can't necessarily go in because they can't get approval because they need to have a certain number of parking spaces. So what happens is you get these older areas that have buildings that can't be reused for many purposes. And because of that, we end up with, somebody once put it, that how do we get our downtowns, our small suburban downtowns, to have more than just pizza parlors and nail salons? Well, the key is, in many respects, you have to think about saying, well, maybe parking in those situations, we should be looking to public parking supply instead of individual parking required for every single lot. Now, the entry, because of the requirement for parking, the entry costs for new businesses and housing units are higher than they would otherwise need to be. So, for instance, in New Jersey, residential site improvement standards, which were adopted in 1997, require a fixed number of parking spaces per bedroom in several land use developments. Okay, and the land use depending on type of development. And they haven't updated those numbers since the late 90s. And that means that whether people are going to use them or not, you have to provide parking. So let's say you're in a small downtown, like a place like South Orange, New Jersey, right next to a train station. Well, unless you get an exception from RSIS, you have to provide parking whether it's going to be used or not. And bearing in mind that people who move into that development may be looking for the ability to be able to go to work and commute without a car, and maybe just have one car instead of two for a couple to just go around places on the weekend. Well, you don't, if every development is required to provide 2 parking spaces, whether they're used or not, then the cost, that has to be paid for by somebody, and the cost of the housing units goes up accordingly. So the Parking Generation Manual. This manual has been around for some time in various editions. It went a long time between the 2nd and 3rd editions to be updated. However, the 4th edition was published in 2010, and the 5th edition in 2019 was just released just before COVID hit. One of the advantages of the new one, now these manuals contain parking generation data for 120 land uses, but half of them have 4 samples or less. And they contain average rates, the range of rates, the 85th percentile rate, and the 33rd percentile rates, and in some cases an equation. Over 50 land uses have at least some time of day data, meaning what percentage of parking is used in any given hour of a weekday or weekend day. Very useful data and information if you want to play around in the world of shared parking. But bear in mind, these are only based on data samples provided for it. Now, the 5th edition that just came out gives you the ability to do some filtering of data when you use the electronic tool. So, conservative approach. We've often focused on the 85th percentile parking demand for setting ordinances to be appropriately conservative. Now, from an engineering standpoint, it is ingrained in our brains early on in our education to put in factors of safety and be appropriately conservative for a reason. I mean, when we're building a bridge or something, we need to have those factors of safety for the unexpected circumstances or some degradation. Samples One thing about ITE is we are an organization of volunteers, and we try to raise all ships and all knowledge. That's Institute of Transportation Engineers, a community of transportation professionals. We have taken great strides to recognize and acknowledge and serve members who aren't necessarily engineers. Okay, so we haven't taken the word engineers out of our name, but the bottom line is we are transportation professionals. Sometimes we're planners, sometimes we come from geography backgrounds, sometimes we come from other backgrounds, but we are all trying to serve transportation. But we've often relied on our members to help raise all ships and to give us the ability to advance knowledge and belief. Now, part of that is we take samples from our members to go into these publications. It's data that is collected. Occasionally there's calls for data, and we give information and some background details on it, but there is no ITE police. We don't go out and we don't verify the data usually unless there's something wrong with it specifically. We don't verify unless questions are asked. We take our members at their word when they submit samples. And in many respects, we live with what people are willing to share with us. There may be, in many respects, conservatism in the sample process selection itself that goes with these sites. Why? Because if I'm going to go out and conduct studies of sites, I'm going to take active ones. I'm not going to take ones that I know are going to be quiet or not very busy. Part of the reason, well, most of the data is collected by professionals who are trying to serve a specific application as the applicant or a concerned third party or the representing a municipality for a specific use. Well, the key is we want to be conservative in our approach. If the ITE data is not available for specific land use, or if there's a question about whether your area is similar to the overall geography, well, the answer is simple. You go look at some similar samples, and that's what ITE data tells you to do. Collect local data to supplement the data in parking generation or trip generation, and if not, go sample some sites. Well, when you sample those sites, you're not necessarily going to sample sites that are too quiet because you want to be conservative. You want to be appropriately conservative. You want to get ones that are busy. And the other problem with it is sometimes you don't know if a site only has limited parking, if that is somehow contributing to the problem. But the last thing you want as a professional is to have somebody undermine your data with a bunch of what-if questions or just pointing to the site you use. So all of this, what is the bottom line of all this? It leads to a whole lot of unused parking in our communities. We usually have about, within most communities, at least 3 parking spaces per vehicle. Most of them are unused a lot of the time. So parking demand, here's the one interesting thing I've found, spending time with the data and looking through it. Bear in mind, the data that we have that go into these publications, we don't toss it out oftentimes because we don't have a lot of data samples. So a lot of this data that's in there is 40 years old or more. So, and parking demand is going down. This is a trend that is going on. And this is all before COVID. The last publication came out before COVID hit us. So the 5th edition parking general manual, you can filter the data by age of data, and you can do it by geography. And this allows you to do some trend analysis. I've spent time doing some trend analysis. And for some key land uses, there has been a trend towards less parking. And it's really likely due to phenomena such as online shopping. Right now, Amazon, or at least when that data was available, had less than 10% of the marketplace captured. And it already had big impacts. Amazon or other online shopping opportunities. Now with COVID, people actually are doing more of it. They're having groceries delivered. They're having all kinds of things are being ordered online now. The pandemic has accelerated that trend. Telecommuting or working from home. This is something that has advanced slightly over time with technology. as we've been able to decouple our offices and not have to work in one place and be able to process information electronically and move all our data to virtually or to the cloud, it's allowed the possibility for people to be able to work from home. The pandemic that we're experiencing right now has totally accelerated this process. And a lot of people do not expect that to end once the pandemic's over. They expect that a lot of people will have readapted enough that they do not want to go back in and work in office settings. And companies may take advantage of the situation to cut rent costs and other things and the cost of having employees by allowing a lot more working from home and outsourcing as much as you can. Alternative modes of travel have also played an impact, including ride-hailing services. We've had an expansion of micromobility. Bicycles are not really micromobility, but we've had other ones, which have given people new options. We've got a lot of new bike lanes on our roads, but we also have had ride-hailing services such as Uber and Lyft. Smartphone technology and applications have allowed us to eliminate or provide the ability to get travel on demand without having to keep a car around, which has allowed a lot more last mile service. And that has had impacts. These have all impacted what's going on with our parking. And I've had people talk about how things are different, how even before the pandemic, shopping centers didn't seem as crowded, especially on Saturdays. So with that being said, let's move on to looking at what I found. For suburban office complexes, parking demand is down approximately 1 space per 1,000 square feet. And I'll show you the data specifically in a minute. For suburban shopping centers, December parking demand, which is what we've often designed parking around, ordinances around, is down approximately 2 spaces per 1,000 square feet. And non-December parking is down nearly 1 space per 1,000 square feet. For suburban location, low-rise multifamily residential, parking demand is down 10 to 20%. And these are all pre-COVID, and these trends are only going to continue to accelerate. So what I've got here are graphs based on time for suburban offices. The blue is the average or median parking demand per 1,000 square feet. The orange is the difference between the 85th percentile and the average. So when you look at the complete graph, you're looking at the 85th percentile, but because of the color coding, you can see what's going on with the average. As you can see, in the 80s, we had about, the average office building was using about 2.5 parking spaces per 1,000 square feet, but then the range of samples would mean most sites were accommodated that would use 3.5 parking spaces per 1,000 square feet. Most real estate developers would look for 4 per 1,000 as their bottom line standard. 90s, not much changed except a little, shall we say, regression to the mean as we tried to take paper out of our office settings. 2000s, our average went down. This is when telecommuting started taking off and our ability to do information technology. But then our high end went up. And part of that was the fact that people tried to consolidate offices. Come 2010 to 2018, things really dropped off. A lot more information technology and sharing, a lot more shared hoteling spaces in offices where you don't have a dedicated office, a lot less paper in offices, a lot more road warriors. You suddenly see that the number of parking spaces needed on average was now below 2 parking spaces per 1,000. And the 85th percentile is below 2.5, probably about 2.3. Suburban shopping centers on Saturdays. In the 80s, we would need, half the sites would need 5 per 1,000, and 6 per 1,000 would be the 85th percentile. That's a number I'm very familiar with. What we saw in the 90s was a drop to maybe 5 per 1,000 being enough. Then when we get to 2000s on, when we get the advent of online shopping, we suddenly are down to the point where we only need on average 3 parking spaces per 1,000 and 4 per 1,000 to accommodate the 85th percentile. In non-December, 4 per thousand was always enough. Well, that didn't change much in the 90s, but in the 2000s, that's gone down a whole parking space per 1,000 square feet with 3. Suburban low-rise multifamily parking demand. What you found was that we're actually starting to see a reduction of the number of parking spaces per dwelling unit coming down. We've always needed, at one point in the 80s, we needed about 1.5 per unit. That went up to about 1.7 and or 1.8, came back down to 1.5. Now it's down to about 1.2 to 1.3. So recommendations. What do you do with this information? Number one, where you can, update your parking ordinance requirements. What you're doing is you're holding back potential development for no good reason, okay? And redevelopment. Redevelopment is a huge opportunity now. Use the difference between the average parking rate and the 85th percentile rate for land banking. So land banking is a situation where you design the parking, but you don't build it until it's actually needed. Well, there's a lot of good that can come from that environmentally and from not building all the parking you need. Allow the leasing of parking at shopping centers during weekdays for park and ride uses or other uses based on ITE data. You've got a lot of information where shopping centers can be used to accommodate overflow parking demands for other users. Give credit for on-street parking, transit, and walking, especially in older downtowns. And shared parking credits. You now have a lot of information where you can share parking. You can get smarter by actually letting uses share parking and taking that into account, especially in mixed-use developments. A lot of ordinances are out there that allow you to share that parking between, tell you what percentage of parking you need to have at certain times of day. And you can kind of just do some quick math and make that work. So that's my presentation. Thank you.
Gordon, fantastic presentation. I had to get myself off mute. We're going to actually, Gordon, you're going to go over 3 questions, and we do have questions on the YouTube chat that we're going to go over. So, Gordon, you're going to say your question, and then you're going to post it for people to respond to. So, let's go with the first question.
Okay, so the first question is, where do many parking space ordinance requirements come from? A, 50th percentile parking demand. B, 85th percentile parking demand. C, average parking supply for existing developments. Or D, Ted Ehrlich made them up 50 years ago, or 45 years ago. So once again, where do many parking space ordinance requirements come from?
Okay, so just post that right now on the YouTube channel.
Already done.
Perfect. Let's go to question number 2.
Question number 2. What has been the 40-year trend for shopping center parking demand? A, continuous decline. B, increase then decline. C, continued increase. D, decline then increase.
Okay, did you post that one?
Posting it now. Forgot to hit enter.
And by the way, Gordon made sure that it's in caps, so you can't miss his post. All right, let's do the third question, and then we're going to go to the chat room.
Okay. Oh, too many letters. Okay. So what changes can be made to ordinance parking requirements for the future? A, reduce ordinance requirements for parking. B, add shared parking credits to ordinances. C, land bank parking for difference between 50th and 80th percentile demand. Or D, all of the above.
Okay, great. All right, now let's go to the chat.
Oh, actually, there was a couple of questions that came in during the presentation, which we might want to address now.
Yeah, let's do that.
The first one was, I believe, the first one had to do with residential. So Richard Newhouse, I guess the question was, family autoship ownership change should justify parking requirements residential. I will tell you that later in the presentation, when you ask the question, we address multifamily. There's not really a lot of good ITE data for single family, at least not that I looked at. And Kevin Roseman, if online shopping is affecting parking demand, wouldn't that also affect trip generation? I learned a long time ago as an engineer, never answer a question you haven't actually investigated. Don't speculate. So the answer is, you'd have to look at the data. You could do the same thing with trip generation. My only problem is I think most of the December data for trip generation is really dated in the trip generation manual. But you'd have to go through the same exercise using trip generation data. Thanks, Luigi.
Oh, no, you got one more. John Kovar says, what is the data source for the parking demand presented?
The data source is from the ITE Parking Generation Manual, 5th edition. And the key is that there's an app that comes with it where you can actually filter your data based on age. And that's where this data came from.
Okay, fantastic. And that concludes our first presentation. Thank you, Gordon, and stay tuned for the panel. So let's go back to the studio. So our next presenter, let me just go to my list here. Jason Sudi, National Lead, Transportation Technology Planning. He'll be presenting Parking and New Mobility. A new reality makes all the new rules. So with that, let's go straight to the presentation.
Hello, welcome to Parking and New Mobility, New Rules for a New Reality. Today we're going to be talking about the interrelation between parking and new mobility and how new technology is going to impact much of what we think about, not only for the quantity of parking, but the way that we're going to interact with our streets and sites in the future. My name is Jason Sudi, and as you see, I'm the National Lead for Transportation Technology Planning at HDR. I'm excited to be with you here today to talk to you about something that we've been spending quite a bit of time thinking about and analyzing and trying to understand how we can move forward in this new world and this new reality, and thinking back on the way it was and the way it's likely to be. So let's think about the reality of today in parking. I know you've thought about this certainly extensively for those of you who are in the realm of parking. ITE certainly is a leader in this analysis and in the understanding and function of the way parking interrelates with our land uses. And as we know, today, the reality of parking, particularly in much of our outer belt or less than thoroughly urban areas, whether that be suburbs or whether that be slightly outside the urban core, it functions in the way we see in this picture. There's a lot of it, and most of it is unused most of the time. Of course, we didn't just get to this overnight. This is something that happened as an evolution over quite a lot of years. And it doesn't go back just a couple of years. It goes back many, many decades. As you see by the vintage of not just the architecture, but also the cars in this picture, we were stacking up cars outside of uses where we arrived via individually driven automobiles for a very long time, well back into the World War II and certainly post-war era. And that became the norm, as we all thoroughly understand. That being said, we are on the cusp of having new mobility fundamentally break that relationship and change the way that we not just think about understanding parking, but what can we do with the land and the access that we used to have to dedicate specifically to the way that parking worked. We're going to talk about three things today. One is just a little bit of parking basics for context. I know that other presentations in general and today have talked about the specifics of how we can address the changes in parking demand going forward. So we're not going to spend too much time. We just want to get the essence of where we were, where we're headed, and how we can change that as we go to the future. Secondly, we're going to talk about the influencing technology, the important things that are evolving and how those are most likely to impact what we see as the main aspects of parking. And then finally, those impacts. What are those parking impacts? What will happen as far as how we need to think and reconstitute the way that both our street grid and our sites are working? So with that, let's just talk about some of the parking basics, things that many of you, I'm sure, already know. I just want to get us all on a level set playing field as we go forward here over the next 20 minutes. Well, the first thing is, of course, how are these parking requirements typically determined? Well, they're based on a set of uses. And those uses, as you know, from your use of the ITE parking manual over the years, they're based on observations and the way that these elements typically function. They are pulled from sometimes a larger scale or coordinated district or campus-wide plan, but most often they're done in very broad categories that are referring back to the way uses typically evolved all the way back from 1940s, 1950s, and those were largely codified by many cities up through the 50s, 60s, 70s. Not to say that cities haven't modified those since, but I think a lot of us who work with cities all the time are pretty well aware many times those parking codes are really stuck in the past and have lagged there, in part because the technology hasn't changed very much. We'll talk about how efforts to decrease individual car driving have largely not gone very far, but how that's on the cusp of really morphing into a new era. The other thing that's important to think about is the separate uses are often requiring separate parking. That's not always the case as we are evolving with shared use parking manuals. Certainly ULI has been utilizing that. Urban Land Institute has promoting that for many years. ITE as well is moving into the shared parking realm, understanding that you can overlap these uses. The problem is, though, fundamentally, individual humans need to get into individual sites. And while I've shown you so far suburban examples, and that is, of course, a huge part of where our parking is throughout the country, this also holds true for urban examples in that we have to locate parking garages and or on-street parking in places that are close enough that the average person will go there and will still feel comfortable going in there and accessing that site. We are, unfortunately, conditioned to be pretty lazy when it comes to the distance we want to go from where we park our car to where we can get into that building. And while we do have some great success stories of high percentages of mass transit in our most dense urban areas, as we're well aware, for the majority of the country, that only goes so far. Once you get outside of dense urban areas with really successful percentage capture on mass transit, a lot of people and most people are driving themselves. And so parking becomes that dominant feature. So what is the result? Well, again, I'm not telling you something that you don't already know. This is a typical case example of a mix of uses development. It's not mixed use because there are really a bunch of different uses next to each other. Whereas I think as planners, we typically think of mixed use as being truly integrated. These are things like hotels and restaurants and movie theaters and residential and all that type of stuff in a suburban style setting directly off of a freeway. And guess what it ends up being? No surprise, 55% of the flat area of that surface ends up being parking lot. And that is in part dictated by our codes, but it's also dictated by the practical reality of the way that individuals driving to individual sites want to get close to the front door and get in and out and then drive to the next use. You can see very much by the layout of this, it's probably not highly likely that someone who is using different uses throughout this site would even park once and walk throughout this contained site, let alone if they're going to a completely different site that would be across another major roadway. It just won't happen. So let's kind of wrap up the rest of this thought process on sort of the parking basis. So we talked about there's high ratios of parking to land use that is historically based on the fact that we have these separated uses. Also, excessive parking became seen as an asset. We were planning in many cases, particularly when you talk about retail, we're planning for that day after Thanksgiving. Now, we acknowledge there have been some changes, particularly in office uses over the years, where in some cases, things like call centers or dense open office environments have actually required an increase in parking in some suburban locations per square footage because you don't have as much common space and that type of thing. But in general, I know because of the research we've done, the amount of parking that is required is almost always in excess of the amount that actually gets utilized in a daily basis or in a large scale approach to those areas. So as I mentioned, more empirical observation approaches have been developed, and that uses more fine-grained categories, and organizations such as ITE and ULI and APA, American Planning Association, have really led the way in thinking about that change. And we're going to talk about that in just a moment. So let's talk about the new mobility influence factors. As a city planner, I certainly have always advocated for the ability to reduce on-site parking by having access to active transportation and transit. And I also acknowledge, as a practicing planner for many, many years, that those have had pretty limited success outside of certain applications. As I talked about earlier, some urban areas have really great transit that effectively captures a large percentage of the population. We also have to acknowledge that outside of those areas, transit captures a much smaller amount of people, particularly when they're making convenience trips, which are outside of their daily working commute. Biking, again, it depends on whether or not you have a fairly successful network of on-street and off-street bike lanes and ways to access certain areas that you can capture a larger group than just your hardcore on-street biking commuters. And again, it's been pretty limited. That being said, there it is, limited impact. That being said, just arrived are things that have really broadened that category. Particularly these micromobility options like scooters and like electric bikes, all of a sudden you're seeing a significant uptick in people utilizing those in order to not just get around to convenience and fun trips, but also get around to things like doing their actual shopping and going to work. We were all a little bit taken by surprise, I think, a few years back when all these scooters just got dropped across the entire country in one sudden fell swoop. Most communities were fairly unprepared for that. And I think most communities were also fairly unprepared for the tens of millions of individual trips that would be taken with those micromobility uses. The interesting thing about that for us as planners is now all of these spaces that we were creating for active transportation to hopefully reduce the dependence on individual driver trips that was largely going unutilized during big chunks of the day is now suddenly getting much more utilized. You've got these PEVs, personal electric vehicles, that are utilizing that space and starting to expand the group of people who will take that. In addition, shared mobility just arrived. Uber, Lyft have become ubiquitous. And again, all of these things have been influenced, as everything has, by this last year and the craziness of 2020. That being said, those are trends that seem to have locked in a certain group of mobility users that are not as dependent on using their individual vehicles to get to the places that they were going. So those types of things have had a much greater impact than we saw before, and they will continue as that idea expands. One of the things that is a result of that is we're starting to think of how to integrate some of these mobility opportunities in things like mobility hubs. And you're seeing mobility hubs pop up in more and more planning approaches, both in large-scale transit plans, in individual site planning, and as we start to think about ways that we can integrate electrification and charging stations into the larger transportation network, how those things are going to work as we go forward. So what's on the way? This idea of sharing your mobility is just being broken into now with these personal electric vehicles and with transportation network companies like Uber and Lyft that are broadening our individual choices and also the collective choices that people are making. Now, this, of course, is particularly effective in urban areas, dense urban cores, but also urbanized areas outside that, first ring suburbs, and really just any place where there is a significant density of people. That does change to a certain impact when you get out into the more far-flung suburbs, and then particularly in the ex-urban areas. Understandably, that level of density is going to change the way that this impact happens and the way the adoption happens. But in the overall scheme, let's think about the two ways that we are likely to see incredible impacts on parking based on the changes that are in front of us. One of those is this idea of MaaS, M-A-S, mobility as a service. that goes back to that shared concept. The likelihood that individuals will not be owning their own cars, or if they do, will not be driving them as often without being part of a larger system where they can pay for mobility. Just like we do with Uber and Lyft now, we'll punch a button on our phones and that mobility option will arrive. And as I think we've all seen, many cities are now starting to integrate both the planning and the payment opportunities to plan things like Ubers and Lyfts, along with things like scooters and electric bikes and transit, so that you're all in one integrated system. And that is almost certain to become the norm in cities throughout the country. In addition, of course, what's, that big rock on the horizon that, is the major influencer that, of course, we're all anticipating is autonomy and autonomous technology. The interesting thing about autonomous technology that I really want to point out today as I go through the remainder of this time is that the eventual goal and the eventual sort of inevitability of having these individually driven, self-driven cars that will allow us to really flex the way the system works is a bit of a ways down the road. And I know you're saying, well, how many years down the road? None of us are quite sure, but what we do know is that things are going to happen between today and when we eventually have this highly automated system that are going to be massively impactful that we have to consider right away. One of those things is self-parking. Before we have these large-scale implemented autonomous vehicle fleets that will help to facilitate mobility as a service, we're going to have a lot of people owning their own cars that will have the ability to self-park. We're already seeing some tests of that with different manufacturers, and it's inevitable that that technology will start to get integrated into cars. So even though there's a long turnover in fleets, which is typically over a decade is the average time for us to turn over the fleet in the United States, there still will be many, many users that are coming in that will be adopting self-parking technology. So when you start to think about that, plus the ability of people to start adopting mobility as a service, all of a sudden we're really going to start to see some impacts in our overall parking demand. Now, this is a general graphical illustration. This isn't intentionally is not giving us specific years on this graph because I wanted to show more of the interrelationship between the adoption of autonomy and the reduction of parking demand. One other thing I should mention in autonomy is so far we've largely been talking about the way individuals, humans, get from a place to another place. Hugely important in the way we think about parking. Just as important in the future, and really starting now, is the way goods get from one place to another place. And we're seeing a rapid increase in the creation, the testing, and the implementation of autonomous delivery opportunities as e-tailing becomes a much larger percentage. And of course, the pandemic of the previous year only served to speed up the pace at which e-tailing was taking place and the percentage of things we're buying. So as you see in this illustrative graph, whether you take a conservative approach or an aggressive approach to parking or to AV adoption, there will be parking demand reduction that takes place as that occurs. Different uses will take place at different times, and that's one of the more interesting things that we need to contemplate. What we're starting to do is to think about how those different uses are likely to be impacted most significantly by the adoption of not just autonomous vehicles, but mobility options in general. And there will be different impacts if you're talking about residential, if you're talking about different types of commercial, and if you're talking about industrial. One of the things that is a huge factor now is with the advent of e-tailing and so many more people buying things online, we're seeing a significant shift in the land use patterns where places that were retail are becoming less customer forward and less successful in the quantity of retail in individual communities. At the same time, the need for more urban style warehousing is increasing as all of the big delivery players, and you know who they are, Amazon and Walmart and all of the mega suppliers of our e-tailing space are looking for ways to distribute more easily and more closely to the consumer. So each of those is going to have a different impact that's going to be related to the overall parking. So what's going to happen? Well, today, we already have too much parking. we have inefficient, underutilized parking. It's outdated codes. And also, we have this need to be proximate to all the uses. Think about a strip mall and think about that example I showed earlier and the fact that individual users need to go close enough to each individual door that they feel like they are getting the appropriate service and the ability to carry their goods back out. That's just one example. Well, changes are already happening. Many cities are contemplating reduced parking requirements. The parking minimum is under challenge in many places as we're realizing that we're already overparked. We're contemplating shared parking. We're also doing targeted redevelopment. I'm sure many of you have gone back to a place that was a big box store or a strip mall and been, hopefully pleasantly surprised to see they've taken a huge chunk of that parking lot and maybe demolished one of the stores or two of them and created a much more dense, urbanized type environment. Perhaps it's residential, perhaps it's mixed use. That's already happening. So we know that that's on the way. What's going to happen in the transition, this midterm time? That's the most fascinating time to get from here to when we really have a huge adoption of autonomy. One of the things is we're going to see increasingly dropping auto parking demand. And the reason I significantly meant auto parking is that we do have to contemplate what's going to happen for the vehicles that are doing all the delivery, but that's a little bit outside of what we're specifically talking about today. Also, increasing use of these alternative transportation modes, PEVs, the personal electric vehicles, mass, mobility as a service, those things are going to just keep growing. There's no indication that they won't, and then increased automated delivery. So the changes that we're going to see are increased redevelopment of these sites. As parking needs keep reducing, that means we're going to keep having excess parking. That 55% of the typical suburban site that I showed you earlier is suddenly going to become largely available for redevelopment. That means we could densify the portions we already have, and we could consider infilling in those areas. Of course, that begs the question, do we have enough demand in all these areas to do so? A question that's valid and something we certainly have to think about. Also, site modifications, building access, the ability for freight delivery to happen. And by building access, I mean the access for individuals to get in, because if you have a car that is self-parking, it will then be able to drop you at the door and go and park in another part of that parking lot. Meaning that we really have to think about the site access being more focused toward that pickup drop-off, so Portica shares, things like that, and less focused on long lines of parking that are outside every door. We can relocate that parking in a large area to one portion of the site for those cars that can self-park as we're transitioning through that autonomy. And then finally, right-of-way modifications. How are we allocating our right-of-way as we start to think about more people using personal electric vehicles, more cars becoming autonomous, and more automated delivery occurring? Adoption long-term, when we finally get there, we're going to have off-street parking, on-site that is, largely reduced. So off-street parking that's required for, say, a shopping mall or an office complex, that probably won't be around very much. That being said, we're going to have to figure out where those go. We'll talk about that in just a second. Also, on-street car parking, virtually eliminated. There will be almost no use to have on-street car parking because the mobility as a service in dense urban environments will be the primary methodology for the way that people will get around. So the changes are storage and charging for shared vehicles. When we have these shared vehicle fleets, we're going to have to store them and charge them at times when there's not high demand, which means that we could identify marginal development areas where they could go that would not impact our overall value of land and instead be utilized in those locations. Also, key garages with much greater efficiency, because if they're self-parking vehicles, that means they can park much, much closer together. Also, autonomous delivery zones and travel ways for those autonomous delivery vehicles will be important to identify so that we can accommodate the ever-increasing prevalence of those. That's a whole different presentation, but it's important to note that that really is increasing at a rapid pace, and all the major companies are testing out autonomous delivery vehicles. Finally, pick up and drop off, both on street, at sites. The way that people will want to access things is right there at the front door. And a summary of that for you is this slide, which tries to encapsulate all of those different elements into an overall parking impact phase approach that thinks about how we access sites today versus how we're going to access and park sites in the long term. So right now, you have some active transportation, some mobility as a service, and almost everybody is driving their own car and parking it. typically. In that midterm, you're going to see an increase in the active transportation, a significant increase in mobility as a service, and an increase in self-parking, which is that partial autonomy. Looking long-term, radical changes where, again, the active transportation portion will keep increasing, mobility as a service will vastly increase, and there won't be cars that are driven by individuals and parked anymore way down the road. There will be at least it'll be self-parking, so that you will no longer have to have that circumstance where you're finding the spot as close as you possibly can because your car is decoupled from where your landing spot is. So with all that, let's just wrap up with a couple other thoughts. A summary of the way these things are going to change. The streets, we're going to be able to repurpose parking lanes, tactical transit, autonomous delivery, personal electric vehicle use. We're already seeing those things be integrated into our right-of-ways now, and it's more important to think about how we'll integrate them more in the future. And then building access, pickup and drop off, and delivery. And how are we going to change with sites? Repurposing parking, extra compact development, more public uses. That could be parkland, it could be open space if there's not enough demand in that area in order to accommodate more development. And then, of course, site redesign, the pickup and drop-off areas, freight access, as more delivery may take place out of some of those sites than it is just for people arriving there. And with all this being said, we've really focused on sort of these different types of development sites. What I want to stress, though, is great urban design and great urban form is still going to be the key to the most success long term. The great news about this is that we have the opportunity to start to decouple the way that we design sites from the need for large scale amounts of parking near front doors. Once we can do that, we can start to iterate our design and our philosophy in a way that harkens back to getting the great urban spaces we want while not reducing our ability to get there from a mobility standpoint. So we can take these reductions, we can make the site design modifications, and that can lead us into a new realm of district design and phasing strategies for our cities that allow us to succeed in the ways that we're trying to accomplish this. That's it for today. I am Jason Sudi. Again, thank you again for taking time and allowing me to speak to you on this topic. Really great to be here at the conference and look forward to your questions. Thanks.
Jason, actually, one second. Great presentation. And I'll have a comment for myself. We're having a parking panel and we're downstairs in a subway station. If you don't recognize it, we're in City Hall. But so Jason, as part of our panel, not panel, but Q&A, 3 questions, and let's go through it. Question number 1, you're going to say it, and you're going to post it on the YouTube chat.
Absolutely. The first is, what are some coming transportation technologies that will most influence future parking?
Jason, I can't hear you. Can you repeat that again? You were off.
Sure. All right, I'll give it another shot. What are some coming transportation technologies that will most influence future parking demand? Can you not hear me?
You've actually run into a technical difficulty.
Not muted, so I did post it.
I can hear you.
Gordon, can you just talk for a quick second?
Okay, great.
Yeah, I can hear Jason.
All right. I'm going to post the second question.
Okay, Jason, it's actually working. Ask the second question. It's on my end.
And then the third question is, what is mass and how will it influence parking in urban areas? Those are my 3 questions. Back over to you, Luigi.
And ask the third question, Jason.
Yep, I just posted it.
All right. I'm going to get back to the studio. Just keep asking the questions. I'm having a slight technical difficulty, and we're going to go to our last presentation. The last presentation is going to be brought to you by Nick Mazenga from Kimley Horn. He's going to be presenting the future of parking technology. So we're going to go straight into the presentation.
Hello, everyone. My name is Nick Mazenga. I'm with Kimley Horn, and I'm going to talk to you today about the future of parking technology. Today, what I want to leave you with is an overview of parking and the parking technology industry. I want to spend some time discussing the future of parking technology and share my thoughts on the parking industry and the impact from connected and autonomous vehicles. And lastly, I want to share with you all some of the major trends that we're seeing in the industry currently. The parking industry as a whole, it's constantly changing and transforming as new and existing technologies are being transformed and rolled out. Some of the areas that I'll touch on today include parking guidance systems, license plate recognition, and frictionless parking. So how much do we actually know about the future? I love these pictures here. They really kind of set that example here. But I was asked to speak about the future of parking technology. But in reality, the future is something that is very hard to predict, as you can see from these now dated popular science cover pages from the 50s. These images serve as a really great example of what people thought the future was going to look like back in the day. And the things are certainly very different. So everything I say here, please take with a grain of salt, because technology changes so fast that making predictions can be challenging. But it doesn't mean that I'm not going to try and give you some of my thoughts and perspectives on it. So what is parking technology anyways? The industry as a whole encompasses everything that I feel touches or relates to the use of technology to facilitate parking. There are two main divisions in the industry, and that is on-street parking and off-street parking. So think meters on the side of the road and parking garages. Both of these types of parking facilities have overlapping needs, but they also have very different uses and operations, and we'll touch on some of those. And I want to be very clear in the distinction between both of them. One thing I also do want to point out is that the parking industry would not be where it is today were it not for the tolling industry, to be honest. The parking industry has leveraged technology developments in the tolling industry from day one. There's been about a 10-year lag in technology adoption between the tolling industry and the parking industry. Many of the wireless payment enabling technologies that we find in the tolling industry that are pretty common have made their way into the parking industry at some point. The parking technology industry has also not been shy about borrowing technology from the hotel industry as well. Yield management, it's a term very familiar in the hotel business, where prices are dynamically set based on demand. Very simple process there. So dynamic pricing has been making inroads into the parking industry as of late. And there are a number of new companies out there that are bringing the years of hotel industry yield management technology and analysis into the parking industry, which is something that's definitely new. So before we dive into the parking industry, I want to point out a very big distinction that I alluded to earlier. In case you haven't caught on to it in all the other earlier presentations, there is a on-street parking ecosystem and there's an off-street parking ecosystem, and they're very different from one another. On-street and off-street parking should not work. It should work in a cohesive ecosystem to enhance the transportation experience, to ensure properly functioning parking system. On-street and off-street parking should include the following elements that you see here on the screen. On-street parking, it's ideal for short-term parking, and the higher costs reflect the value of that easier access. There's also higher turnover rates for on-street parking to increase that parking availability. On-street parking can also be characterized by an increase in rates and fines to promote that parking compliance. So off-street parking, it's ideal for those longer-term and commuter-style parking applications. It is characterized by lower hourly rates that enable longer-term sessions to occur. In an off-street parking environment, the lower parking turnover rates are acceptable. Pre-booking and yield management for large events is also ideal and provides the opportunity to help increase the parking efficiency in an off-street environment. If there's one basic takeaway that anyone can leave with today, is that there are major distinctions between the on-street and off-street parking market. And this permeates through everything we do in the parking industry. So on the topic of parking industry trends, the International Parking and Mobility Institute, or IPMI for short, which I'm a member of, did a survey of its members to identify what were some of the top emerging trends in the parking industry. So full disclosure, this data is from 2018, but even today, if you talk with a parking professional, these top emerging trends, they still hold true. So parking technology, it remains this game changer, and tech-based trends include the prevalence of mobile apps that provide real-time information on pricing and availability, technologies that improve the access control and payment and demand for guidance systems as well that help drivers find parking. So many of these technology improvements, they dovetail with the parking industry's drive to make parking more environmentally sustainable by reducing the time it takes to find parking, decreasing fuel consumption and fuel emissions. And it's important to note that especially for this audience, about 40% of the respondents that you can see here report noticing increased collaboration between transportation decision makers as this landscape shifts. So what does that mean to me? It means that I can see even more collaboration between my parking professional colleagues and those attendees here from ITE. So the curb, as you'll see, is a big game changer that's noted on here. It's always been there. Everyone knows it's always been there, but it's getting way more attention these days, which is clearly evident by what we have heard from other presenters today. So curb management, it's emerging as critical, especially in municipalities. There's a rapid TNC growth and expansion into multiple markets for that curb space management. Airports and hotels, they're also feeling that brunt. Take, for example, any airport in the US, pre-COVID, mind you, and just observe that Uber, Lyft pickup or drop-off areas. It was very congested. Lastly, pricing for the curb will change. I think if you're going to see more dynamic pricing for curb space, and pun intended, to curb demand. You're also going to see more flexible use of those spaces in the curb. The curb has become the latest parking area of discussion, and how you manage the curb is now an even bigger part of a municipality's parking responsibilities, for one example. With the rapid growth of the gig economy and meal delivery and pickup services, like Uber Eats and Grubhub, to Amazon Prime, there's an increase in competing interest for that curb access. Everyone wants to get to it. Several cities have undergone curb management pilots like Washington, D.C., Seattle, Columbus. Most recently, I was supporting the city of Seattle with a rollout of their pilot curb management system for their commercial vehicle loading zones. We worked with them on helping develop a new policy and commensurate technology that went along with it for those commercial vehicle loading zones. So lastly, the big takeaway here regarding curb management is this foundational principle that you see here. Because at its foundation, parking and curb lane management seeks to ensure equitable access to the curb for all roadway users by taking a much more holistic view of land uses and the demand for accessing the curb. Strategic reallocation of the curb space can be made to ensure people have safe and easy access to the places that they want to go. That's a very important thing here. So, moving on from the curb, EV charging is becoming a bigger and bigger component of the work that we are doing in the parking technology world. On the parking technology vendor side of things, we're seeing more traditional parking access and revenue control system vendors, or parks vendors as we like to call them. They're getting into the EV charging business, whether it's through an acquisition or it's through increased partnership and systems integrations between the folks who are opening, closing the gates, and then the folks who are providing that electric vehicle charging infrastructure. On the parking facility side of things, where the electrical design for parking facilities, it was once a very cookie cutter experience. It's transitioned into something much, much more. We're seeing a lot more what I would call future proofing of parking facilities for eventual build out of expanded EV charging facilities. We're accounting for it with larger electrical rooms, higher capacity cabling, and increased conduit sizing in the parking structures to allow for that future proofing. So think of any garage today that's being built. It's going to have about a 40-year bond on it. So in that time, the evolution of the garage may see a greater percentage of those spaces being dedicated and switched over to EVs. And that will be a lot of juice that is going to need to charge all those vehicles. So, next time a 3,000 space garage is built, I really hope the power company is thinking about, well, what kind of induced demand that may bring to the grid one day with all those EVs in there getting charged. I mean, we could spend an entire conference discussion just talking about V2G or vehicle to grid. This is another area to keep an eye out for. And this is the notion that all of those batteries in the garage could one day be used to balance the loads of the grid and help with peak power demands and store energy during times of low cost power. For some perspective, there are more than 1 million EVs on the US road today. By 2040, it's projected that over half of all passenger vehicles sold will be electric. So almost every new garage we're designing these days has some provision for EV charging stations, a small percentage right now. Early on, it's a simple amenity that some facilities they installed with 1 or 2 spaces. We saw this early on, but then EV charging used to be this nice amenity a property owner could then advertise and show and maybe garner some added business and say, look what we have. This is a free service. But now there's a prevalence of charging by the hour because they want to increase that vehicle turnover, because at one time people were just sitting there all day, but now we have more EVs out there. So I think we're going to continue to see a strong growth in the market to install EV charging stations in most all parking garages and parking facilities. So frictionless parking. What is frictionless parking? This next video example I want to show you is a demonstration of a frictionless parking system that uses license plate recognition, or LPR cameras. This is a garage in Germany for a shopping center that has entirely no gates. So when you leave, you simply punch in your license plate into a pay machine or into an app, and the system knows what time you entered based on your plate, and it gives you a fee amount. Then you pay that and you just drive away. The sign at the exit, as you can see here, acknowledges that you paid. But if you leave and you do not pay, like you see in this white car just did, then the LPR camera picks up your plate and a message goes on the screen and says that if you do not pay, you will have to be fined something like 30 euros. It's a very high amount. So it does encourage people to go back and pay. As you can see, this person backed out. So this is an example of frictionless parking. There's no gates, no nothing, just drive in and drive out without having to wait. So license plate recognition is one of the foundational elements of any parking technology system. We rely on license plates both from an enforcement standpoint and from a credential standpoint. Here's a good example. In newer parking systems, say you pull into a garage and you pull a ticket. Then on your way out, you pay at a parking machine, a pay on foot station, in a lobby or in an elevator area. You pay that ticket, or you use a mobile app to just scan your ticket and pay for it. Then when you're driving out, magically, without having to put your ticket in the machine at the exit, the gate just goes up and you drive out. So this is done using license plate recognition cameras, and this is a very common application of them. The system knows that you paid for your ticket because when you entered, they printed your license plate on that ticket, and the system knows that this ticket tied to this plate is okay to drive out. So when you paid, and then the system just lets you out automatically. But how accurate are these systems? That's always a question we get about LPR. There's a degree of error with the cameras and their ability to read all plates. In the US, we make it very, very difficult for all these cameras to read all the plates because we have so many variations and symbols and states, et cetera, and so forth. In Europe and almost any other country, they have very, very simple license plates on the front and the back. Those are required in very contrasting colors that are easy to read for these cameras. Their plates are actually optimized for license plate recognition. In a perfect environment in the US, under the very best conditions, under lighting and everything, A license plate reading camera is really only going to be able to pick up between 93 and 97% of the plates that it actually sees. And you also cannot control something or someone who has a bike rack on the back of their car or something like that. So it's not perfect, but it's a great tool to improve the efficiency of a parking operation. So parking guidance systems. I'll be upfront with you and just tell you, I love parking guidance systems. These are ubiquitous in almost every parking facility in Europe or Australia. The concept is very simple. And if you have ever driven through a garage that has a system like this, it's, in my opinion, a huge stress reliever. We're seeing more and more US garages looking to install parking guidance systems, or having them considered at least during the design phase of a parking deck. These systems are not cheap though, and they can cost anywhere from $200 per space on up to $1,000 per space, depending on the accessories and the signage you put in. So to put something into context to that number, the average cost to build one parking space in a deck today, or structured parking, not surface lot parking, but structured parking, it's around $19,000 to $22,000. So that extra couple $100 sometimes isn't that big incrementally, but every little bit adds up when you do add into a system like that. The benefit of these systems is that they allow you to fully maximize your parking facility. It reduces the stress in drivers, and it's environmentally sustainable. So no longer are you having people idling and circling around looking for spaces. These systems expedite a parker to a spot very fast, thereby reducing the vehicle emissions. The numbers we're seeing on systems like this include reducing that time to find a parking space by up to 90%. And this equates then to emissions reductions by as much as 70%. So there are some real added benefits to these systems. Where you typically see these systems in the US is in airports and the healthcare environments. On the healthcare side of things, it's a great patient and visitor amenity to have a parking guidance system, because I can't tell you how many times I've struggled to find a parking or navigate my way around a healthcare campus. And I'm a parking professional, mind you. So if I'm having trouble, then you know others are having trouble, the same challenges. So that's my plug for parking guidance systems. I think there's a great benefit to them. There's also a place and time for them, understanding that the costs do go along with them. So back to IPMI, when they did the survey of their members to see what their thoughts were on the future impacts from AVs and the parking industry, so autonomous vehicles. If you want my honest opinion, we're in the 30-year camp based on what numbers are shown here. My rationale for this is the vehicle fleet turnover. It's just something we can't change right now. So if you think about it, any new car bought right now today is not fully autonomous. And that new car you buy today will likely still be on the road for another 10 to 15 years. So that is 10 to 15 years from now. Then you're in the market to buy a new car. For the most part, your car 15 years from now may or may not actually have full autonomous self-driving capabilities when you're going to buy that next one. So I think you'll see a large offering from all vehicle manufacturers for near autonomous driving capabilities, mind you. But this will likely be limited to the luxury and high-end markets. So we're still 20 plus years in from your basic model Kia to have full autonomous driving capabilities that will be affordable on a mass scale. So even then, there's still the question of what the actual market penetration is for these autonomous vehicles. So you got to keep that in mind to make a significant impact. Is it 5% of the total driving fleet? Is it 50% of the total driving fleet? It's not yet known what this percentage is that will correlate to the significant impacts for the parking industry. So put another way, how many people are comfortable with cruise control and use it on a regular basis? This is a generational shift to move toward that comfort level. And it's going to take, I feel like, a long time to get to that point of AVs making a significant impact. So maybe when I'm retired, I'll be able to relax in my autonomous vehicle and will get me from door to door with my eyes closed. But I don't see any major impacts, at least to the parking industry, coming soon our way. So when these AVs do show up, and they eventually will, and I'm not disputing that point at all, they will have an impact on our overall parking and transportation infrastructure. So nearly all the respondents that were polled did agree that autonomous vehicles will have a significant effect on parking, transportation, and mobility, but opinions vary from there. About 60% believe autonomous vehicles will create congestion at pickup and drop-off areas, but 45% feel consumer reluctance will delay the car's widespread adoption, something that I feel pretty strongly about based on my last slide I showed you there. About 20% predict many more autonomous vehicles will be on the road within 5 years. And others feel that change may be, 10, 20, or 15 years. More than 60% predict parking lots and garages will become transportation hubs where people will park cars before selecting other transportation options for the last leg of their trip. So all that to be said, respondents, they were skeptical that driving and the need for parking will disappear in the near future. So these are just some of the perspectives based on IPMI membership and what they thought of it. So with that, I just want to thank you for this presentation. We're going to open it up to questions after this. So thanks.
Nick, thank you. Great presentation, and was able to fix that glitch. Unfortunately, my Bluetooth went out, so I had to hardwire the speaker. So with that, let's go through our series of questions and start off with question number 1 and then post it on YouTube.
All right. So for first question, name one frictionless parking technology. And I'm going to post that up there. And then let me get question 2. So for question 2, what is one of the top emerging trends in parking technology right now? And I'm going to post that up here. Well.
Excellent. I haven't seen the second question just yet.
All right. And now the third question. How accurate can license plate cameras be, or LPR cameras? So give a percentage or percentage range, and that will satisfy that answer.
Excellent, excellent. So what we're going to do, just keep answering, please. And if you have any additional questions, we'll try to respond to them. So we're going to go straight into the parking panel, so we can actually end a little bit early. So now I could actually say my joke. We did an entire parking panel in a subway station. So, so Gordon, just sound test really quickly. Gordon, can you hear me?
Yes, I can.
Jason? Jason, are you there? Okay, good. Jason, we can't hear you. Did you just say anything?
Yes. Yeah,
perfect.
Yeah.
And Nick, you're good to go. All right, so let's start off with the first question. And please post any questions you want to ask the panelists on the YouTube chat. All right, from a ride-hailing services perspective, to what extent will they be playing in the parking world? Is there a downside to this? Nick, you want to, or Gordon, with Jason?
Yeah. Regarding ride-hailing services, I think, specific to the airport market, one of the interesting things we saw is that, okay, we have this huge queue of vehicles and there's a huge queue of passengers, and we need to get these ride-hailing vehicles very close to where the pickup location is. So we're seeing more and more airports. I mean, obviously, the cell phone lots have been overwhelmed, but we're seeing more and more airports put those ride-hailing services very, very close to the terminal, very close to that parking area. But what it's also doing is that's eating up parking demand for your passengers who are flying into the airport and also want to park there as well. So we're running into a situation where we're doing more and more charging. So we'll geofence that area, and then the ride-hailing services are going to have to actually pay for the use and access to that curb. And charging for the curb is the biggest thing, that's going to try and help with that management of the curb. Just like parking as well, you got to charge the appropriate amount for parking. You also got to charge the appropriate amount for the curb space.
Yeah, and I think it's just a precursor to more mobility as a service, which will then eventually decrease the parking numbers. The one spot I did want to mention, in addition to the airports, is that you're seeing a lot of hospitals now that will designate TNC drop-off. So right there is a campus area that's clearly not getting that parking demand right now because a certain percentage of people are arriving via TNC. And again, that's a bigger social question as to some people are avoiding the heavy fees associated with ambulances, but ideally a lot of people are just using that as an option to get there if they don't have the opportunity to drive. So we are seeing those impacts now, and I think that's just going to accelerate.
Yeah, I'd have to concur that I think, first of all, the data I looked at already shows an impact, and it's only going to increase going forward. There's a great article in the ITE journal that just came out, the February edition, and it's all about parking demand at limited service hotels. And I think that really the use varies a lot by land use. Okay. So certain land uses more than others. But the one interesting thing is this article said that travel and business expense service providers Certify found that of the 3 ground transportation segments for business expense reimbursement, meaning what business people are doing, from first quarter of 2018, the share of Uber and Lyft combined was 71% of the ground transportation share for business travel. That is big. Now, with COVID, I think there's some concern about sharing space with another person, but at the same time, I do believe that the driver in the Uber and Lyft model is temporary. They're eventually going to replace it with autonomous vehicles. So I think that the trend is here to stay, and it's going to impact our sites. And I think that you got to maybe think about the reduced parking demand creates the opportunity to start creating space for pickup and drop off, such as taking a bunch of spaces, numbering them and reserving them so that people can, so that you don't have to do it. The biggest problem I've seen right now in the here and now is the clogging of the circulation aisles.
Okay.
People pull up on the curb, and a lot of sites weren't designed to have constant parking and maneuvers next to them.
No, great. I haven't seen any. Here's a question from James Carr. Do you envision traditional parking lot designs requiring designs to better accommodate new parking technologies, demands, and automated vehicles?
I think the answer I just gave is before that, and I'm sure James typed this question before that came out. It says it all. I mean, a lot of times we just a lot of sites do the bare minimum they can get away with by law. All right, let's be frank. A lot of standards for aisle widths and whatnot don't contemplate a whole lot of curbside dwelling of vehicles, and that's become the real problem that needs to be addressed in going forward on new sites.
Mm-hmm. And then one thing on the parking structure side of things, there was the last maybe a couple of years of the parking structures conferences, everyone was talking about adaptive reuse. We're going to build these new parking garages. They're all going to have flat floors because someday we're not going to have parking demand and we're just going to fill it with office space or something. So there was a lot of talk about that and a lot of talk of how do we structurally build these garages so that they're ready for when there's no parking demand. Well, as the math came out, they started looking at the cost of, all right, how much does it cost to build this very, adaptive reuse garage? And then how much does it cost to tear it down and just build something new at the time when there's going to be enough density? And we're not seeing a ton of adaptive reuse garages. There's a lot of talk of them, but we're not seeing a ton of, the private side saying, let's build this adaptive reuse garage. So I would like to see more, but I just don't think the numbers are there yet.
Well, the other problem with that is the fact that office space right now is a white elephant. I mean, the truth is COVID has now changed the future projections for office demand substantially.
Sure.
Well,
the other thing that Nick brings up an interesting point on, we're seeing in developers that we're working with, and also just in boards and commissions that we're parts of, that developers are now starting to look at decoupling the interrelated floors of parking because they can see where that can be a problem in the future. But building a side-by-side garage, that the numbers just pencil out where it's cheaper to build that garage, as long as you can do it in a way that you can demolish and not affect the other structures you have. So I think you're right. And on surface parking, to the question, I think you are going to start to see areas where certain portions of that surface lot will be dedicated to different types of use. So you'll have your traditional parking lot for regular cars, and then you'll have at some point in the future that says, okay, this is where automated or self-parking vehicles can go, because they can jam themselves in and you can get 60% more efficiency. So just like everything else, I think it's going to be a transition.
I mean, that was something I was just going to lead into is, what challenges do you foresee moving forward in the age of COVID? Planning parking, implementing and using technology. I mean, I think we sort of answered that, but if there's anything you want to add to that.
Yeah, not really.
Okay. All right, so I guess this is a hot button one. How about this? Do you see the use of technology to reduce, parking costs? Curbside and also...
This is a yes and no question. Yes and no.
Yeah.
And I'll have the other panelists give their more specific analysis. But from the big picture, my thought is that you're going to start to balance some of the demand with the supply because of economics. And if there is demand to do construction in areas where you have surface parking, then a lot of that parking is going to go away. And so you're going to sort of balance out how much you have. Now, the garage aspect is a different one. I'll let Nick take that one on.
Yeah. So it's an interesting point, and Gordon kind of mentioned a little bit of like, all right, with an autonomous vehicle, it's going to drive itself. It's going to park itself in a very tight spot, so your square footage demand is no longer there. One thing that we are seeing now with some of our parking clients is they're just making it work really well with an expensive valet operation. They're saying, you know what? I only have this much space, but I got to park this many cars. What do? They hire a bunch of valets and they just throw a bunch of money at it to make their space work for them. Maybe, over time, those valets, they just start to be pulled out of that situation, and then they're using just, the autonomous vehicles to park themselves. So we may already have that like capacity there for, really tightly packed parking decks. And maybe over time, those garages and those lots are going to get a little bit smaller. I think in the near term, we're just throwing, resources and people at it to make it work, which works in the near term. But in the future, we might get even eke that much more capacity out of our decks and garages.
I think, okay, so I'm going to get more generic and high level. So if you look at our urban form and how we've developed in a car culture world, we have at least 3 parking spaces for every car, all right, out in the world right now. And that's a lot of land area taken up. And all parking aisles have to be designed for the worst case driver to be able to turn in and out. Like our parking aisle of 24-foot width that we use as a standard, that's based on like a Ford F-150 pickup truck or a Lincoln Town Car turning in and out of a space. That's a lot of utilization of land that gets expensive. There's a hidden cost to it that's never really calculated. And that's where the real change is going to come. First of all, with smarter use of parking. And the other thing about cars is they tend to be parked like 95% of the time. So they're in motion a very small percentage of the time.
Yeah.
So the key is if the car doesn't have to be tied to the use or the land use, it can go off by itself and park. You can get a much more economical distribution of land and value. I mean, even just getting us from 3 spaces per car to 2 would be a huge improvement in terms of the utilization of land. And what that does is that means we can move buildings closer to the street and have less parking, and people can walk between stuff easier and, further reduce the demand. So I think, ultimately that, shall we say, more efficient use of land and resources and not having to having cars self-park and not have to use those huge aisles and get a lot more utilization will invariably lower the cost of parking.
No, great. I don't see any other questions on the blog. So, last question. This is a simple one, I guess. Should we be using the parking generation manual to plan future developments?
Let me address this one because that was my presentation. Here's the thing. We have to understand, and everybody needs to know, that our parking generation manual and also our trip generation manual are really just an accumulation of data points. As professionals, we need to question whether that data is relevant all the time. My advice, first of all, the best thing ITE did was actually give you these apps you can use with the latest trip generation manual and parking generation manual so you can filter your data. All right, we have to make do with what we have. And I got to say that one of the things about, statistical significance, I've often thought through my life what a horrible life it would be being a statistician. What's it like going through life knowing you're right, but that nobody cares? We make do with very limited amounts of data. Number one, the first thing I would do is, if I'm trying to use that publication, accept it for what it is and filter the data. Make sure it's current. Make sure it's relevant. And don't be afraid to go collect new data and feed it back into the publication. Because you know what? That average rate, like we shouldn't just be pulling numbers out of a book. This is not like research on impact attenuators based on tons of auto vehicles deciding what thing to hit, like what striking force or what angle cars will hit it. This is something that, we're just using the data for what it is. Let's not be let's do our best to get rid of old data. And because a data sample from 1980 may still be weighing into the average rates published. Well, you know what? Get more data. Go get as much data as you can. When you do a parking study, factor in going to count 3 similar sites at least, so that instead of just saying I'm going to use the book and try to reduce my costs, and try to
and your the similar sites comment I think is really important, because I think there's going to be a huge gap that's going to start taking place if you're urban, if you're suburban but with an urban bent, if you're truly suburban, if you're ex-urban. That's where you're going to start to see a wide divergence of parking requirements, I think, as you go over the next 20 years.
You're right, Jason. And the other thing is, feed it back to ITE. Make everybody you're better off. But the bottom line is, okay, we're trying to design sites. You know how much money developers, our clients, save if we can reduce their parking demand, rightfully so, by 1 or 2 spots per 1,000? I mean, it's worth the time to go collect some data. Matter of fact, the benefit cost ratio, I don't want to calculate it. It's huge.
And I'll throw a plug in there. I was speaking about parking guidance systems, and the cost benefit ratio of of a system like that, where you are using every single last space. You're not having people circulate around looking for a space and they miss it. Space by space parking guidance systems, they are expensive. They're not a cheap thing to get, but they are this one thing that allows you to take that car on the side of the road and put it in the very last space and not have them circle around looking for it. So, getting the maximum utilization out of your structure, I think, will help, because then that'll take that percentage down of, what's that fluff? Are you saying 90% occupancy is full? Well, now you can actually fill up every little last space. So maybe those are some of the things we need to look to change is, what is full? Is 90% full? Is 80% full? Or is 100% actually full?
Right.
That's a great point, Nick.
I can't say how many times I've done a parking survey throughout my entire career, and I can't wait to use all this technology, and hopefully we can share more data so we don't have to perform as many counts. There is a couple of questions that I'm going to turn over right now. One from Brian. He's got question: EVs, AV license plate. Actually, sorry, wrong one. This is James. Do you envision traditional parking? Which one? Oh, sorry, wrong one. I missed the one. Richard, has the security of AV been addressed, particularly with self-parking? That's the last question that was asked.
That's a big question
that's
right there.
My punt on that.
To say everything's safe. I'm not a network security expert, and I'll be front and center to admit that. But every computer is going to have its faults. But at the same time, I think understanding that we still live in a society where we hand our keys to a valet and we're cool with them taking it and parking it, I think we should also understand that our car will go pull into a garage and can park itself. So that's a big one. I don't know if I answered your question completely, but maybe give some perspective to it.
The other kind of perspective on that is the way our parking lots are set up right now in a surface lot situation. It's a terrible situation where almost every, say, retail store, everyone's crossing the main entry path in. So I don't think it'll be any more dangerous as long as the self-parking is governed at a very low speed. Because right now you're basically putting everybody in harm's way every time they go to a surface parking lot. So again, is it perfectly safe? Probably not. What we have now is definitely not safe.
With that, I don't see any other additional questions. So I think we're going to end the panel. I wanted to thank you for the presentations and a great discussion today. And an applause, and I wish I could do that. And hopefully everybody will do that on the YouTube. Well, thank you all.
Thanks.
Now we're going to go back to the studio.
Thank you all so much.
Okay, thank you.
Marvin, well, that concludes the end of our presentation. I'd like to turn it over back to Marvin, our president, for closing statements.
Thank you, Luigi. I hope everyone enjoyed today's session. I definitely want to echo Luigi's comments earlier, thanking all of our guest panelists for their informative presentations, as well as the thought-provoking panel discussions. It was really interesting, and I hope everybody sincerely enjoyed that. I also want to take the opportunity to thank our volunteers on the technical projects and professional development committees for their efforts to make today's programming possible. So thank you to them as well. Before we end today's conference, I did have one final announcement that I'd like to make. We do have another great event lined up for you next month. It is the MetSections Industry Day event, and it's scheduled for March 11th. So please save the date on your calendars, and please keep an eye out for any future communications and announcements from the MetSection in the coming months. So again, thank you all for joining us. I hope you enjoyed today's session, and please have a great afternoon. Thank you.
Thank you all.